Live right now.
Okay.
And it says going live. Any minute now, we'll go live. I'll bet we're live right now.
Hey.
Says we are. Hello, everybody. Welcome to Blue Marble. We are joined by Farmer's Boy, Judy Bassett, and Moyock Man. How's everybody on what's today? Tuesday afternoon.
Doing his finest.
I want to go home.
Farmers is being held captive in Wales.
Yeah, I want to go home.
Moyock is hiding from Pete Shea. I don't know why. Judy's here just to lend moral support, I think.
I'm feeling fine as frog hair, split 3 ways.
All righty. Anything interesting going on out there? Not much.
It's raining.
Yeah.
That's about it.
Yeah.
Starting to think, based on the evidence, that the world might be flat.
Huh?
I'm starting to think that the world may not be flat.
Oh, really?
What do you think?
Now, whatever would lead you to such a silly conclusion?
A whole bunch of things. Even my observations with my eyes have seemed to point me in that direction.
Well, that's really going to disturb some people, you know? I'll bet there's a whole server full of them out there somewhere right now talking about level being horizontal.
I can't find it again, but there was a great video I saw from the cockpit camera in time lapse. And if you watch that, and if you watch it, perspective unfolds, you can actually almost see the curvature of the Earth. It becomes evident that you're going over a curved surface. Wow, that's really kind of cool.
Yeah, it's it's such a silly idea. I don't know why we even bother talking to these idiots. But we do. I'm not sure if there's maybe not more wrong with us than there is with them in a way.
Yeah, there could be something in that.
But hey, you need something to do, right? Can't just be sitting around doing nothing.
My wife certainly thinks there's something wrong with me talking with idiots all day.
Yeah, I like Alan Evans has got an audio tape, audio cut of one afternoon several years ago when his daughter walked in and very loudly said, "Are you talking with retards again?"
That was just one of those moments, because I think I was in on that stream at the time, and yeah, she just walked in and she has, with her accent and her sort of turn of phrase, priceless, absolutely priceless.
Yeah.
And I can't argue with her either. It's like, I can't say what good I'm doing for with my time.
Yeah, it is kind of a dead end road. It doesn't matter how many times you tell these guys. They reset every night.
Yeah.
And conversely, though, she does play The Sims, and if you want to look at that, it's just about as bad a waste of time. Just a different time. And just as valuable.
Yeah, I was watching the Try Thinking show yesterday, and they had dredged up a video from almost a year ago now, done by F.E. Dogma on the LIGO installation up at Hanford. And he did an analysis that was pretty similar to the one I did on LIGO down in Louisiana, showing the same thing.
Oh, yeah. Yeah.
But Bev and company, of course, butchered it from one end to the other. So I thought at some point we might just play F.E. Dogma's video and listen to it without all of Bev's interruptions, because it really is a pretty good analysis. And it begs the question, why would you go to all the trouble of pouring a pad with a big whopping curve in it if you didn't need to?
Yes, because it's a lot easier to pour concrete so that it doesn't have a curve in it.
Yeah. Even if it's sloped, I mean, just a linear slope would be easy.
Yeah.
Why would you bother putting the curve, especially a curve with that radius, if you didn't need it?
Well, you wouldn't, would you?
No.
You wouldn't go to all that effort just for shits and giggles.
I would.
Well, yeah, I suppose you might, but generally people don't. It's not worth the aggro. Unless, of course, you need to for some reason or other.
I'd like to say hello to Steel City. Can you talk to us? Maybe not. Might not have a mic. Yeah, somebody keep an eye on the Discord. Maybe you'll talk in Discord. I can't see it right now.
No, well, I'm in Discord because obviously I've not got me usual setup as I'm stuck in this grotty hotel room.
Yeah,
so laptop.
Were you doing it by phone today?
No, this is my laptop. Yeah.
Oh, okay. All right. Yeah, that'll work. I see a bunch of people out there in the YouTube chat. Rob Parks, Genesis, Hads, Royal Kenny, Grumpy Old Mechanic, Rocky, Christian, and I don't even try your last name, buddy. David Lee Rodman, Sean Hawkins, who else? Gary Little, and others I may forget to mention. Tiny Captain was in earlier. Repo Sandman out there. So if I left anybody out, my apologies. Not intentional. And Gary Wybanger, look at that. Hello, Gary.
Wow.
You are Victoria, says hello. Excellent. Tommy. Tommy says, "Go make a drawing, Gary."
I wish I had £10 for every time he said that. I'd be a rich man.
Hey, Citizen 9, Doc C, and shout out to Digital Demonic Davros for $2 Australian. Hello there, 4:38 a.m. listening to the Smooth Blue. Well, I'm glad to see you, Davros. And believe me, not many people would say that. No, I'm just kidding. Charlie Welch, Barry on. Yeah, good. We're getting a crew assembled.
Smooth Blue. I like that. That sounds like one of those late night radio shows. Hello, and you're listening to Smooth Blue.
Smooth Blue,
I like
10 a.m. to 3 a.m.
Yeah, but going back to LIGO, the lengths that the flat earthers will go to. And I'm sorry, you can correct me till hell freezes over, but you guys claim the earth is flat. Now, don't give me this bullshit about terrain. Yes, we know it's got terrain. Let's talk about the 71% of it that doesn't have terrain. We call them oceans. And you guys claim those things are flat. That's, as far as I'm concerned, makes you a flat earther. So you may try to get away from the stigma of being an idiot by changing the name, but you're still an idiot.
Yeah, and that's exactly why they do it, don't they? I mean, Bevan's crew, will talk about flat earthers as if they're not flat earthers. No, sorry, you are.
Yeah, that's right. That's the incredible dishonesty on their part.
Yeah.
If you're that ashamed of it, stop being like that. I don't get it. If you are ashamed of being a flat earther, stop being one. It's easy.
Considering the amount of effort they have to go to be a flat earther and try to validate their bizarre beliefs and claims and everything else, it'd be a lot easier just to say, no, okay, I accept reality after all.
Yeah, it seems to me like that would be a much simpler approach.
Yeah. Why don't you devote all your efforts to something more worthwhile? Because they do go an awful amount of effort, and you think, why? You're just wasting your time. You're wasting your energies. Why don't you go and do something better with it?
Yeah, like cataloging snails food or stuff like that.
Anything. I mean, anything would be more useful than going, oh, the Earth is flat. The Earth is flat. It's all fake. It's all CGI. Really? That's the best you can do with your time?
Yeah, it was, as we were talking before the show started, I find it pretty amusing that Bev went to the trouble of posting in his Discord this back and forth he had with the Ordnance Survey several years ago. I think that's worth reading. Don't you?
Yeah.
I'll tell you what.
It doesn't make sense, though, does it? I mean, it's like, by the way, in case anybody had forgotten how stupid I am, look at this. It's okay, Bev. We haven't forgotten, but.
Trying to see if there's a way I could, if I could stream it in here, but I don't think I can. Anyway, it's up in the it's on the Discord channel, up a little ways. I'll show it on YouTube. You guys can find it and follow along if you want to. Let's see if I can get it up on the screen for YouTube. There we go. Yeah, maybe a little bit hard to read some of it, but it's it goes back to January of 2020, so over 2 years ago. And this was Bev corresponding with the Ordnance Survey people. And of course he sends them the Merriam-Webster definition of level. He only sends the first of three definitions they provide. Number 3 actually talks about level following the curvature of the Earth, but you never see him post that one.
No, never. They ignore that one for obvious reasons.
yeah, yeah, that doesn't fit with the narrative. So yeah, let's just ignore it. It didn't didn't mean anything, right?
That's it. Correct.
The little blue things are Bev, as he says. Can you please explain why the dictionary definition is so different? Can you please ask for someone who I can talk to about this, please? And Ordnance Survey has a response to that. Wait a minute. Let's see if it's this one. Yeah, it says, thank you for getting back to us. We have forwarded your question through to our technical team for comment. As we previously stated, we are unable to provide a direct contact. All correspondence comes through our customer services team, either via social media, email, or phone call. Okay.
Ah, hang on a minute. I think you've skipped a bit.
Nope. Wait a minute. Oh, yeah, I'm sorry. Yeah, I did. Let me go back. After Bev asked that first question, can you please explain the dictionary definition? The Ordnance Survey response was, the dictionary has practical approximations that can be applied to everyday life where the distances are small, a few meters. Okay.
Yeah.
Now let's keep going. Bev then says, up to 100 square miles, it says here. How is that worked out? Is it 100 by 100 miles area? What the hell is wrong with you, Bev? You don't know how to calculate the area of a damn box? A square, for God's sakes. That is a level of stupid I don't even know how to deal with. Anyway, is it a 100 by 100 mile area, or would it be an area 1,000 by 0.1 miles?
I mean, let's just ignore the fact that 100 miles by 100 miles is 10,000 square miles.
Right, yeah. Skip over that and go back to a number that actually is 100 square miles.
Yeah.
1,000 by a tenth, yeah, that would be 100. That seems bigger than the few meters to me. Is there someone who knows a bit more about this that I can talk to, please? Yeah, there you go. That will endear you to the guy you're speaking to.
Yeah, exactly.
Nice one, Bill.
Okay.
So Bill says, then they say, thank you for getting back. I read that already. I'll just do it again. Thank you for getting back to us. We have forwarded your question through to our technical team, etc. But there is nobody you can talk to. That's essentially what they say.
Yeah.
And I think the next one is this one from the Ordnance Survey saying, we have now heard back. Your quote, plane and geodetic surveying, comes from Wikipedia. Our understanding is that the 100 square miles is simply an approximate rule of thumb as to the size of a survey area that can be treated as a plane without introducing significant distortion errors by ignoring the curvature of the Earth, Bev. Our interpretation of 100 square miles is that it is not 100 by 100 and is instead 10 by 10 miles. 100 by 100 is 100 miles squared. That's correct.
Yeah.
To put it another way, if the survey area is no more than 10 miles on any side, then in many circumstances, notice they didn't say all, in many circumstances, it can be treated as a plane. The applicable size will, however, vary depending on local conditions and the exact requirement and standards that the survey is adhering to. Hope this helps. Oh, gosh. Not to be deterred, however. Again, Bev says, could you please tell me how I can talk to your surveying team, please? The main problem I have is that I understand level to be horizontal and the water level to be the most accurate level over large distances. And the water level doesn't require a line of sight. Okay. I'm not sure why you're going down that path, but I was of the understanding that the Ordnance Survey was the highest authority on land surveying. Should I ask an independent surveying company instead? All right. Way to go. Now you really pissed them off, Bev, because here's the response.
How to make friends and influence people.
Yeah. Yeah. As a result of that, here's their response. Our relevant technical team have already provided several responses to you, you dumbass, and as we've already explained, are not available to speak to you directly. The document, A Guide to Coordinate Systems in Great Britain, and they give a link, fully explains all about the systems for positioning in this country, and we have nothing further to add. If this document is not sufficient for you, or you do not understand it, which is a given, then you should seek out further background. Excuse me. Choke myself. Then you should seek out further background information yourself online, as you suggest, by contacting someone like an independent surveyor. That's just funny.
Yeah.
That is funny. These guys have literally told you to go piss up a rope and embarrassed you by pointing out the fact that you're too dumb to figure out how to work out the area of a square. And now you're posting this in your Discord? What is wrong with you, man? Holy Jesus.
Yeah.
That's just incredible.
I don't understand why he's posted all this again within the last few days, apparently. I mean, it makes no sense.
No.
Then I suppose this is Bev we're talking about, you know. He obviously thinks he's still got a point or an argument or something, but the Ordnance Survey very politely told him to piss off.
Exactly.
Yeah, yeah. They. What? Hang on. Let me click on that again. What's it? He says, our relevant technical team have already provided several responses for you. You know, so you've asked a stupid question. We've given you sensible responses, and you're still not happy. What are they supposed to do?
Yeah. Yeah, exactly.
Are you saying that level is horizontal?
No. He's actually saying that level is horizontal. You shouldn't keep doing that.
Oh my.
It's I thought the level was horizontal and that everybody uses water levels over long distances. Really? Where? I've been in the construction industry 35 odd years now. Do you know how many times I've seen people use a water level on a building site? I can count them on the fingers of one foot.
Exactly.
You don't.
It is never done, ever. I'll tell you this. A guy pulls up on my job site claiming to be a surveyor and starts pulling out rubber tubing. His ass is going out the gate real quick.
Yeah.
That's because you're trying to hide the.
No surveyor uses a water level. That's silly.
Yeah. I mean, I can understand why the Romans used to use water levels, you know. And even then, the Romans had theodolites. You know, they had a setup for doing that sort of thing. And yes, they did use water levels. It's very handy when you're trying to maintain a fixed level round a corner. But you're not doing it over huge distances. That just doesn't work.
If you're sometimes there are reasons for using one. If you're trying to match elevations around the corner of a building or something, that's really handy.
Exactly. Yeah.
That makes it very easy to do. You know, on an industrial scale, the only time we ever used them, and I only ever did it myself a couple of times, was to level up the internals of a device that we supplied. And that was only because the only reason we used it was because the headspace that you had to work in up there was only about 3.5 feet tall. And it had a solid roof on it, and the things you were trying to level were kind of buried down in there. And it was just physically impossible to set up any sort of level optical device. So, the water level came in pretty handy for that. But that's the only time I've ever seen them used. Those special circumstances. No damn surveyor ever uses one. That's just crazy. What do you need that for? You got total stations and all that stuff. I think I missed a super chat back up here. Hang on. Yeah, digital demonic Davros again for another $2 Australian. 10,000 miles. Yes. That is exactly right, Davros.
And of course, as Jens pointed out in Discord just a little while ago, 100 square miles. If you imagine that was the area of a circle around a theodolite, that's a radius of about 5.61 miles.
Yeah.
So because obviously if you're surveying and they're saying, oh yeah, over an area of 100 square miles, you don't generally, unless you want to be painfully accurate, you don't have to worry about the curvature of the Earth, because that's a very small circle. You think, 100 square miles, that's a big area. Well, no, not really. And given the size of the Earth, the curvature over that distance, it probably isn't worth worrying about for what you're doing. As they say, most of the time, you can forget that the Earth is curved because you're not actually covering that great a distance.
Yeah. Yeah, the circle encompassing 100 square miles is not very big.
No.
11 or 12 miles diameter, something like that.
Footprint of a cell site. Going back a few years.
Yeah, I mean, I think it's because you hear 100 and you think, 100 square miles, that must be a big area. Well, no, not really.
No, not in the grand scheme of things. Not a big area at all.
Not when you're on a planet the size of the Earth. Yeah, like they say, for most of the things you're going to be doing, you don't need to worry about curvature because it's that dreaded N word, negligible. It just depends how accurate you want or need to be, and that's what they said in their reply to it.
Well, most of the time we build things level anyway.
Exactly.
And when you're leveling, you're going to do differential leveling anyway, which is going to assure you that you're accounting for the curvature of the Earth.
Yeah.
Because you built it level.
Yeah. It's hard to find something that's not built level.
Any project I
LIGO
work
is a prime example.
Any project I work on.
What kind of stuff do you do?
Last thing I did was built a deck next to my swimming pool.
There you go. You don't really care much about the curvature of the Earth over a deck, do you?
Well, but I didn't make it level. Even with the water reference right there.
Yeah.
Actually, I got fancy with that, and I ended up sort of following the curve of the pool instead of building a square deck. That caused a couple of issues. I eyeballed a couple of things, and I don't do good at it. The end product looks fine. It's close enough.
Yeah, I don't think I've worked on any project where any of the buildings has been that big that you've had to worry about the curvature of the Earth.
No, of course not.
We don't make buildings that big. Even when you think it's. I mean, there was an Amazon warehouse up north, and it was just over a kilometre long. Bloody great thing it was. You didn't have to worry about the curvature of the Earth when you were building it.
Building 4 in Fort Benning, Georgia, just might have a bit of a curve in it.
Yeah.
Fort Benning.
Home of the infantry.
Sand Hill. As I recall.
And OCS, we were just hoping they didn't make us low crawl through the dog training area.
Yeah, Fort Benning's a place. I did some summer camps there. In the reserves. It's not the worst place I ever went to. Certainly isn't the best either.
No, it's not Fort Bliss.
Oh, hell, I did basic at Fort Polk, so nothing gets worse than that, I don't think. They finally obliterated that place for basic training. That was a really good idea, too. Wish they had done it right before I got there.
Yeah, well, they kept my my basic training up. I'm from Great Lakes. So.
Oh, you're one of those Navy guys, huh?
Yeah.
Oh, yeah.
For me.
Well, I've got F.E. Dogma's 12-minute video on LIGO up at Hanford queued up here. Now this time I think I can share my screen.
Oh.
Let me see. So you guys should be able to see that. And I'm going to play a little bit of it and see if you're hearing the audio.
Okay.
This is a photo of the Hanford LIGO Observatory in...
Anything?
Yeah, no, I can hear it. He's hearing.
Huh? Was he just quiet?
We've got the sound, but he's quiet. But
okay.
But he's there. We can hear him.
Okay. Well, I'll go on mute and we'll listen to it. I think the YouTube can hear it okay too.
Good. Washington State. It is an interferometer, and each arm has a beam tube that is almost 2.5 miles in length. Now, the light that enters these beam tube actually reflects between two mirrors at each end about 300 times. Now, it is the alignment of those mirrors that is most critical, and what they did is they actually hung them from a 4-segmented pendulum to help isolate them from outside vibrations. And one of the flat Earth arguments is that this system would only work on a flat Earth because the pendulum would be like a plumb bob, and this would be the only way that the face of both of those mirrors would be perfectly parallel to each other. Of course, a calculation for the globe Earth shows that those pendulums would only be out of parallel by 36 1/1000ths of a degree. I think we have the technology to accurately calibrate those mirrors to the correct angle. Also, they actually have to actively monitor those mirrors during use, and they do this with 5 sensor actuators, and that keeps the mirrors within an angular orientation of 10 to the -8 radians. The beam tubes are the other key component. They are 1.2 meters or almost 4 feet in diameter, and they need to be straight enough so they don't interfere with the laser light. Now here's a very good article explaining exactly how they did the alignment using GPS surveying, and I'll leave a link to this in the description. On page 2 is table 1, which are the allowable tolerances for the beam tube, and this includes the manufacturing process. But if you look here, this is the tolerance from a perfectly straight line that was allowed when they did the final assembly and alignment with GPS, and that was 1.8 centimeters or less than 3/4 of an inch. Now actually at Hanford down here on page 9, they got it to within 1/2 of a centimeter, which is less than 3/16 of an inch. Now I worked in commercial construction on large projects, and that is impressive. Now here's a cross section of the beam tube enclosure, and the closure is a shell made out of concrete. It sits on a concrete slab, and you can see that the beam tube is off-centered. Now after the concrete slab was poured, they used this GPS unit on a card to mark the center line for the location of the beam tube. Now the beam tubes were manufactured in 20-meter lengths, and they would move the GPS unit 20 meters at a time to get an accurate center line position for the beam tubes. Of course, the critical alignment was during the assembly of the beam tubes, and in the photo right here you can see one of the brackets that is at one of the beam joints. So what they did is they actually put a GPS unit on top of the beam tube, and then they used these adjustment nuts right here. There's 2 more on the other side until the beam tube was in the proper position. And the other key component is the concrete slab. Now there are blueprints for these projects that are available to the public, and they show the elevations for the top of this concrete slab. So this is going to allow us to understand whether this project was built on a flat earth or on a globe. I'll leave a link to this website in the description, and I'm going to go to the Hanford Observatory and click on the civil prints. This will give you an index of blueprints, and we're going to start with this one, the drawing matrix. Down in the lower right corner is the number of the drawing you're looking at, and this drawing shows the whole facility, and we're going to take a look at the northwest arm. Now the drawing numbers I have circled in red over here match these drawing numbers in the index. Here is the Hanford LIGO Observatory on Google Earth, showing both the northwest arm and the southwest arm. And I've aligned the matrix drawing so it matches Google Earth. Now I've turned everything so the northwest arm goes horizontally across the top, and here is that matrix drawing. I have the corner station, mid station, and end stations lined up. And what I want to do is start by looking at this blueprint here, which is this segment of the arm. Now down here where it says location confirms that we're looking at the correct drawing, and this lower drawing is the overhead of the beam tube, but I want to take a look at this profile of the concrete slab up above. These dotted lines up here show the side profile of the concrete slab. Along the bottom we have distances that are marked off in 100-foot segments, so this drawing goes from 0 feet to 1,400 feet. Over on the left we have
Hey, Blue,
elevations
YouTube's
that
saying
are
they
10
can't see
feet
your screen.
apart, so each one of these smaller lines represents 1 foot. And at every 100 feet
Yeah, I
we
fixed
have
it.
an elevation for the top of concrete slab. So I'm going to start with this elevation at 0 feet that is at the vertex of both arms. This is a blow up, and we have an elevation of 533.78 feet. And I'm adding that elevation to the corner station on Google Earth. And next I want to find the elevation for these 4 distances. Those elevations are on these drawings. Here are the elevations. Now we can see that the elevation decreases by 4.15 feet from the corner station out to the end station. So let's compare this to the flat earth and the globe models. Now on both models, a horizontal line is perpendicular to a vertical line at the location of a surveying instrument, and on both models, a level line is a line of equal elevation above mean sea level. Now I've added water levels to help explain this, but on a flat Earth, a horizontal line and a level line would be one and the same, and of course on a globe, a level line would curve down from the horizontal line. Let's start with the flat Earth. Now it would make the most sense if we had the same elevation for the length of the arm. Because one of the flat Earth arguments is that the mirrors on the pendulums need to be parallel to each other and perpendicular to the beam tube. Of course, this is not even close to the actual elevations. It starts at about 3 inches right here, and at the end station it is actually over 4 feet higher. Of course, it would be possible to build this on a slope. And these would be the required elevations using the same rise over run ratio. But that does not match the actual elevations. In the center here, we're just a little bit over a foot lower, and on each side, we're just a little bit over 9 inches lower. And ironically, those elevations represent a line curving up, which of course brings us to the globe. And on a globe, a level line of equal elevation will curve down from the horizontal line. So this is a globe level line of 529.63 feet. And this is a horizontal line that is tangent to the end station. Now what I drew down here is just a smaller representation of this graphic up here showing curvature drop calculations. So here I've added the actual elevations of that concrete slab, and what I'm going to do is I'm going to do earth curvature calculations for each one of these distances. I'll add that value to the 529.63 foot elevation and see if it matches the actual elevations. So let's start with this elevation here. It is 3,200 feet from the end station, which is 0.606 miles. I'm using the Metabunk curvature calculator, and that gives us a geometric drop of 0.24 feet. I add that to 529.63 feet, and that gives me a total of 529.87 feet. That is off by only 0.01 feet, which is less than 1/8 of an inch. At the mid station, we have a geometric drop of 1.01 feet. That gives us a total of 530.64 feet, and that is off by 0.02 feet, which is less than 1/4 inch. At this distance, the geometric drop is 2.3 feet, giving a total elevation of 531.93 feet. And again, this is off by less than 1/4 inch. And finally, at the corner station, we have a geometric drop of 4.1 feet, giving a total elevation of 533.73 feet. Now this is the largest difference at 0.05 feet, but that is less than 5/8 of an inch. Now as I said, I used to work in commercial construction. I was responsible for a lot of concrete pours, and 1/4 inch over 10 feet is an acceptable tolerance. These numbers are very impressive over this distance. 5/8 of an inch is not even going to be an issue, because look at all the clearance you have between the bottom of that beam tube and the concrete slab. And what is very obvious is that these elevations do not work on a flat Earth. It would not even work on a flat Earth if that slab was designed as a slope, because it would be just over 1 foot low in the center. So my calculations support what was said on page 3 of the alignment document. The fundamental coordinate system for the alignment was the Earth ellipsoidal model WGS-84. Now I also used these blueprints to do calculations for the southwest arm. These are the elevations from the vertex at the corner station all the way out to the end station. Again, I have a horizontal line that is tangent to a level line. The only difference is the elevation here is 533.78 feet. And these are the actual elevations of that concrete slab. So for the first distance, we have a geometric drop of 0.26 feet, giving us a total of 534.04 feet, for a difference of less than 1/8 of an inch. At the mid-station, we have a geometric drop of 1.04 feet for a total of 534.82 feet. Well, just like the northwest arm, the error is less than 1/4 inch. Next, we have a geometric drop of 2.34 feet for a total of 536.12 feet. Again, just like the northwest arm, an error of less than 1/4 inch. And the geometric drop at the end station is 4.1 feet for a total of 537.88 feet. So here the difference was less than 1/2 of an inch, which is a little bit better than the northwest arm for that distance. Now the maximum deviation for 4 different locations on both arms is less than 5/8 of an inch. And it could be that these GPS elevations are actually more accurate than my curvature calculations. But in any case, 5/8 of an inch is not going to be an issue for the alignment of that beam tube. So I think it's safe to say that the top of slab elevations for those beam tube arms is more evidence of a globe.
And there you go. That was a pretty nice video, I think.
Yes.
Level
Yes, I
line
think
of the
Let
curve.
me pause it. There we go. Pause it for a second. Before we go any further, let me back up. I had a super chat. I wanted to shout out David Lee for $5, who said, "Blue, I don't think we're seeing his video." Okay, yeah. Sorry about that. I screwed that up at the front, at the first of this, but you guys saw the important part anyway. So now back to the content. Yeah, and if a dogma is correct when he says the WGS 84 might be a little more accurate than what he used. He used 3959 as the radius of the Earth. And that's really only true at the equator. So if you go back and check, and it depends too on which direction you're going, you know. If you go back and check it, those numbers are really very, very close when you apply the actual ellipsoid model. Because up there at that latitude, which is 45 degrees, I think, the radius is not 3959. It's more like 3953 or something like that. But again, it depends on which direction you're headed. You know, east-west is a little different than north-south is. So I did the same kind of analysis on the one down in Louisiana at Livingston, with about the same sort of results. It's only, if it's off, it's only off a tiny amount. It was closer at Livingston. I did, like I say, I did a similar thing, but you're closer to the equator down there too.
Yeah.
So you're closer to that 3959 radius that we typically just use. That's not an accurate number, but I don't know how LIGO doesn't convince people that the Earth just simply cannot be flat.
Well, they lied about all the numbers in those documents.
Yeah.
Hey, it measures gravity, for Christ's sake. I mean, come on.
And GPS. That's clearly fake.
Something that could easily be verified from some surveys here. You know, the pad itself is level enough, or I should say straight enough.
Yeah, you can argue about 1/8 of an inch or 1/4 of an inch here, there, or yonder. The problem is the center of that damn thing is a foot too low to be in a straight line.
I am sorry to announce this, guys, but I'm here. Now we can begin the show.
I need to announce this. I am here also.
Gotta go
And-
back and listen to
Well-
Pete.
It's been a good show, Blue. I'll say good night.
And a hearty welcome to Lael and Davros and Shake.
I would like to thank you, Blue, for being a professional pilot, unlike Brian Mabbitt, who thinks he is, but he's not. Flying a radio-controlled plane does not count as being a professional pilot.
Was Mabbitt on about aviation again?
Oh, Jesus. Well, as farmers would say, good grief.
My gosh.
Good grief.
It always amuses me. Of all the things that the flat Earth believes in, things they believe about aviation are
Base of
probably
an
the most
inch is
wrong.
not even gonna. Concrete.
I have a
floors.
question for you, Blue, since you've actually piloted an airplane. I understand, like, around the equator, if you're going 500 miles an hour, that the equator is so large in circumference that you would not necessarily feel the plane banking. But at what latitude would you actually start to feel that?
Start to feel banking. I'm not sure I understand the question.
If it was a flat Earth.
No.
If
At the equator, at 24,000, let's say 25,000 miles in circumference,
yeah,
that's large enough that a bank, you wouldn't feel a bank, right? The plane banking as it makes that turn around the circumference.
the plane's not turning.
No.
Deeping.
It's flying flat and level.
Yeah, it's just flying
Leo,
level.
you live somewhere around 30, 35 degrees north.
32 degrees.
Okay.
So my question is,
Do you feel that big turn to the left when you just stand there and look out down the road?
No. But
Well,
I'm
then
asking, like, so
you wouldn't feel it in an
let's
airplane
take
either.
2 degrees north. If you're traveling at or 500 miles an hour in an airplane, and the airplane's banking to stay on that latitude, would you feel that or no? Is that still large enough that you wouldn't feel it? The circumference of that latitude.
No, there's no way you're going to feel that.
You know what I'd be most worried about?
What?
I'd be most worried about that 10-knot crosswind.
A lot more worried about that 10-knot crosswind, which might not be 10. Wind's aloft, 10 is nothing.
What's 10-minute crosswind mean? I don't know what that means.
10-knot crosswind.
Oh.
10 nautical miles per hour crosswind.
I thought he said minute.
No. No, a 10-knot crosswind is common to have on a runway. At altitude, a 50-knot crosswind is not uncommon at all.
A 10-knot crosswind is something I don't want to mess with right now.
Yeah.
I'll bet.
You'll become
I only
comfortable
use
with that.
4 knots. I only use 4 knots for the missus.
Left lane, when you're driving a truck down the road and you have like a 50-knot wind, how do you feel?
That's pretty squirrely.
I just got my steering wheel at about 45 degrees and my front tires are squalling a little bit.
He drifted.
I haven't done that for a while. I was driving south one day from Wyoming to Denver, and the wind was blowing from the west at, I don't know, it'd be 40, 50 miles an hour. And the problem was that these tumbleweeds would show up and you'd see them in your headlights like 2 seconds before you hit them. But, I mean, yeah, you just turn.
They freak you out.
Yeah, I mean, and like suddenly, poof, and then you hit them and they pop into a million pieces. That was scary.
And some of them are as big as a damn Volkswagen.
Yeah.
That's not a crosswind, that's a tumbleweed.
Yeah.
If I'm driving on a highway and I have a 50-knot crosswind, I'm pulling over, finding shelter, and looking for the tornado in the sky.
Yeah, damn right.
No, they're actually on this particular road, I-25, that gets in that particular section. There can be some pretty strong crosswinds, just stable for quite a while.
Canyons.
Well, not even on the canyon. This is out on the plain, but you're not too far from the mountains.
Okay. I'm convinced.
This
I'm convinced that Wyoming was put on the map to drive through, except for maybe Cody and, that famous place the stars live at. But anyways, go ahead, Davros.
Well,
I turn the time over to you.
I was going to say, at least you guys have an excuse for high winds through Tornado Alley. I think the record in my state here is 127 kilometers an hour. On the beach.
Phew.
We don't get cyclones in my state. That's about 85 miles an hour.
Hurricanes here either.
Oh,
That's
speaking
still a
of
pretty
which,
strong wind.
yeah, no shit. But speaking of which, had to try and explain to them how we've had cyclones on both the west coast and the east coast, and why is it they both tend northwards? They couldn't explain that.
Correct
And
me
always-
if I'm wrong, but on a flat non-rotating plane, there would be no problem with a cyclone or crossing over the equator, right?
They can't. They'll dissipate by the time they get there.
No, I said on a flat,
on a flat
non-rotating Earth.
On a
There'd be
flat
no
non-
problem with that, right?
On a flat
You wouldn't be able to make them.
I was going to say, explain to me how a cyclone or hurricane forms on the flat non-rotating Earth.
Oil field.
No, toroidal fields. Yeah, I know. Gotcha. You said that so convincingly. I thought it was.
Lyle, you've been spending too much time with these idiots.
Hey,
You could just instantly say, "Oh, toroidal field."
Is it magnets or is it electricity? I forget.
That was impressive, though. He didn't even hesitate. I mean, just boom.
No, he didn't even hesitate.
Toroidal
No,
field.
he was out with it. Yeah.
Yeah, I thought he
I don't
said
even know what
toilet
that means,
field.
though. I don't know what a toroidal field even is.
Or
No, but that's the whole point, Lyle. You don't have to. You just
you don't have
somebody
to.
else did.
You just say something, either that or electrics. That's the next one.
That's Pavlov's dog. Come on.
That's a song, though. It's electric.
Come on, I understand electrostatics and water statics and hydrostatics, and it's grease lightning.
Oh, that's
Dude, that
true. I never thought of it that way, but I agree.
Oh dear.
I do not apologise for that dad joke.
Oh, you're not required.
Sure. Yeah, jury's out on that one.
On this show, it's okay to tell dad jokes. We don't mind them a bit.
Most of us are dads.
I got a joke for you, Blue.
Oh, no. You're not going to try to be...
A line of rabbits hopping backwards.
I'm afraid you're going to tell me. Go ahead.
A receding hairline.
Oh, good God. Yeah.
But you called them rabbits, not hares. They're a different animal.
Totally.
Rethink that joke, please.
I'll give him credit. I'll give him credit for that. That's okay. Rabbits are sort of
just a
hair-looking
just a pass,
things.
Blue.
Yeah, hair-looking things.
No credit or
come on.
No credits or distinctions here, mate. Come on. Fuck! I hate straight lines.
Are toroidal fields the cousin of hemorrhoid fields?
Wow.
If you've ever had a hemorrhoid, you will never ask that.
What are you saying? These. Oh, sorry, Blue. You go.
I see this conversation has gone all to hell.
Well,
yeah,
that's
this
I've got
conversation's gone off. Can we have another one?
All right, let's take it from the top, guys. And no layoff.
John Watson for £5 says, Davros, I'll be in your country again soon. I promise to use an ashtray this time.
The country is an ashtray.
Care to explain that?
Okay,
What did
last
John
time
do?
John Watson. Okay, last time John Watson was here, just after he left, the entire country was in flames.
Oh, okay. I remember that.
And he goes, oh, yeah, it was me. Like, as I was taking off, I just flipped my cigarette out the window. And he was gone. Oh yeah, just quickly, I've posted a picture in your live chat there, right? It's an interesting picture.
Let me see. Let me.
Oh, picture, it's not interesting.
Remember how I said toroidal fields? How can a toroidal field exist without a rotating spherical Earth? According to this, it requires a spherical surface to have a toroidal field.
Sky fairies and goblins.
Toilet fields require flushing.
Toroidal.
Turtle fields? What?
The turtle moves.
Well, that's because the toroid is based on the dome. Dummy.
No, it's a Mobius strip.
But it specifically says that it's electrically conducting spherical surface.
Yes, the dome. Come on, man.
Anyway, if anyone has seen the picture that I posted in Blue's Discord, when Demok saw that, he went absolutely bananas.
Can you give me an example of Demok not going absolutely bananas?
No.
Because I was actually, hang on, Blue. Sorry, I was actually talking to them when I took this photo out the front of the workshop. Right, there's the moon, and there's a particular planet directly above it. Off to the right, there is a bug.
It wasn't a video. It wasn't a video. Where's the video?
Yeah, that's what I copped.
CGI.
But also, do you know what's making that pink stuff underneath?
The toroidal field.
That's the question. Where is the sun in this picture?
Oh. Riley says Riley says that's redshift.
Yeah.
That's because it's twilight sunrise.
But later,
That
when the
is a
sun comes
very
up,
cool-
you get blue shift, which is why the sky is blue. That's what Riley says. Anyway.
That's true. That's what he said.
Well, the sun
Shout out to
approaching with redshift. So that makes sense.
No matter what shape the Earth is, that's a cool picture.
And a shout out to the Stingray for 5 pounds.
Oh, jeez.
Demonic
Not that
Dad
guy.
Rose, please try and keep John Watson, please, forever, please.
No, Stingray. That's not going to happen. He's yours.
No, he's not.
Yeah, that is a pretty cool picture.
Yeah, it is. Yeah, somebody was saying yesterday on Geos that the crescent moon is impossible on a globe, on a spherical Earth, in the heliocentric model.
How?
And there it is.
Wait, I just see it. So how's it impossible?
Yeah.
And here's what's interesting.
The sad thing is you can physically model some of this stuff, and this is the kind of stuff you can model with a tennis ball and a flashlight.
Yep.
What is interesting is the amount of light below that, how I was able to capture both those objects. The sun was diluting the light pollution just enough that I could see the images.
Was that like a 10-second time lapse?
No, that's a single shot from a phone.
So you're looking
It looks
east.
like multiple shots.
You're looking east, so that would be a waning
It's coming up. That was
Yeah.
taken in the morning.
Right. Looking east.
But yeah, it is a waning moon. Yeah.
Waning moon, right. So you were seeing that even higher up in the sky earlier, right?
Actually, it would have been more to my right, believe it or not.
Yeah, I believe it.
Because of its current position around the globe, it's not quite coming up east and west. It's slicing.
If it's the sun rising, the moon is rising also.
No, the moon's already risen.
Well, it's moving up, not down.
Well, it'll actually move up and to the left of that picture.
Yeah, and if you look carefully, you can see the moon is where you think the moon isn't.
But it's pointing to the sun.
Yeah, but also has Earth shine.
Right.
If you look closely.
The sphere pointed anything down.
Oh yeah, if you actually zoom in on that photo, you'll actually see the full circle of the moon.
I can see it when I'm zoomed out.
I can
There
see
you go.
it I can see it when someone pulls down their pants.
Oh jeez.
Oh, let me give you a video share.
Show us a picture.
Where can I
Blue.
see this photo you're talking about?
The one of me or the
live
one
chat
of the moon?
Discord.
The one that you're talking about on Discord.
In Discord, in the live
It's in
chat,
live
chat
chat.
group.
Sorry. Live chat.
Yay, Brian Leakey's here.
Top of the list.
Live chat.
Yeah, he is.
What's up, B. Ryan?
Hey, Brian, is that really how you pronounce your last name, is Leakey? Or is it pronounced?
Yeah, and I don't know if I got good audio.
You're kind of quiet. It's kind
Look.
of muffled.
You know, quiet.
Just yell like normal, and you'll be fine.
I know. Yeah, y'all give me 2 minutes.
Is a globe. There is no doubt. There is no question. It's where all the evidence leads. Go from there, Brian.
I have a question for Brian, unrelated to the shape of the Earth. Where does your name come from? Your last name.
It comes from the Leak family, which was the band.
I think he's not there anymore.
Hey, shout out to David Lee for $5. He says, "Hey, Blue, do you still have that picture I emailed you a while back?" I just looked and I don't see it, David. You want to send it again? I'll try to show it. Maybe. Yeah, what happened, Brian? Having trouble?
Yeah, he's having audio issues. He said he'd be back in a minute.
Yeah. Good. We can have a nice discussion.
Mm-hmm.
Or a dumpster fire. Or whatever. You never know how it's going to go, do you?
No.
Hey, Blue.
Yeah.
Why can flat earthers not answer the question, how far is too far, when speaking about how far we see?
I don't know. Because there is no answer? How's that?
I mean, we can see the sun, which is 3,000 miles away. Why is that not too far, but seeing from New York to London is too far?
I can see
Yeah, well,
further
how
than
far
that.
is Sirius in Orion, or correct it? How far is the middle star in Orion's belt as it sets in the east?
42.
42.
Which is 9 times?
What?
That's the answer to the universe, 42.
And that's right. And the question is, what is the answer to 9 times plus?
9 times plus? 12.
9 times 6. Why is 9 times 6 equal to 40?
Here's the Brian Leak family story.
I've never put my finger in a dike.
Did you know the sun has a toroidal field?
I'm not opposed.
It's interesting. I found an article called "The Formation of Sunspots from the Solar Toroidal Field." It's in 1954, and its reading is way above my head. So maybe Blue can do it and make an experiment.
And maybe not.
Why not, Blue?
I don't know that I possess the capabilities there, my friend.
You did it with the Cavendish. Why can't you do it with this?
Well,
What, sunspot?
I could try whittling a sunspot out of a chunk of sapele, I suppose. I'm not sure what it would look like. Oh, I know. I just need a hole saw. That'll do it.
Yeah.
Why not?
Blue's the first person ever to create an artificial toroidal field due to sunspots.
No, I think we're not going to be going down that path. Pretty sure.
Sounds pretty hard.
Yeah, I'm trying to get figure out a way to download an image that David sent. Silly ass thing.
Good evening, gentlemen.
Hello, Alan.
Good evening, Alan.
Is Alan here? Hi, Alan.
Yeah. Sorry I am tardy, but...
You're not tardy. You arrived exactly when you wanted to.
I told you, Flat Earth is full of tards.
I think that's the wrong definition for tardy.
I think so, yes.
Yeah, you guys carry on. I'm trying to copy an image here.
Damn it, I need more tea.
I'm working on it. Let's see.
Oh, look at that.
All right.
That's a cool picture too.
Yeah.
Yeah, so I've actually got it up on screen. Only YouTube's not seeing it, so let's see if we can.
12/7/21. This has to be CGI.
There you go. There you go, David. Got it up. Good picture.
What's wrong with the 12th of July 2021?
Yeah, I was going to say, what's wrong with the 12th of July 2021?
That's superimposed on the picture, therefore the picture is CGI.
But it could be the 7th of December.
Well, yeah, it could be.
I think he means that the numbers are floating in air.
Yeah, therefore the whatever explanation for the numbers is, that means the picture is CGI.
Are you trying to fill in for flat earthers who aren't here?
What do you mean? I'm filling in for Brian.
We don't. Please don't feel that you need to. You know. That is a nice photo.
Yeah, let's see. David said where it came from. I'm taking over Kenya, I think. Yeah, 39,000 feet over Kenya.
I would really rather enjoy being in an aeroplane at 39,000 feet over Kenya.
Got to be better than being at 0 feet in Kenya.
It's difficult to be at 0 feet in Kenya. There's not much of Kenya that is. Just the beach.
Well, you know what I mean.
You know. Yeah. Most of Kenya's pretty high up in the air, isn't it?
I suppose so, but I think I'd rather be flying over it than walking it.
Yeah, well, I'd much rather be flying over. Well, no, because I'd actually enjoy a visit to Kenya. I think the trip to Kenya would be really nice.
I want to announce something very important here. On Google Scholar, there are 655,000 hits.
You're going to say to draw your
universe.
fruit?
No, for the electric universe.
Two Left Thumbs wants to know how come that horizon looks curved.
Yeah.
Well,
I noticed.
Yeah, I did get invited out to Kenya quite a long while ago. But unfortunately, I couldn't afford to go.
Yeah, that's fair enough.
Oh, I forgot about Rwanda.
Yeah, I
Those
don't
that giggled know what I'm referencing.
David Lee says his son took it and he was there for a few weeks tracking cheetahs.
Oh, wow.
How do you know the cheetahs weren't tracking you?
How can you track cheaters? They're cheating.
Yep.
Well, was it the just buying a bag of chips in a supermarket?
Yeah, nice picture.
Cheetah.
We need a bigger boat.
I suppose, in all fairness, cheaters most of the time aren't running, so.
They're actually sleeping in trees.
It shouldn't be too difficult to track them.
I guess it depends Oh, I guess it depends on whether they've been given one of those fancy radio tracking collars or not, doesn't it?
Or
Yeah.
you got between that and a gazelle, maybe.
I'm told those things run pretty fast.
Oh, it's CGI.
Aren't they the? Are they the fastest land animal? I think.
I believe they are, yes.
For a short distance, anyway.
Oh yeah, yeah. They try not to run too fast for too long because you're burning up a lot of energy.
I don't know. I think Chemo might be the fastest land animal. He can dodge faster than anything else.
I mean, yeah. You raise a valid
You
point.
might be
yeah.
right about that.
I think Pete's worse than Chemo with that.
No, but Chemo sucks his teeth before he goes faster.
Yeah.
That's a telltale sign he's about to lie.
Yeah. Sucking of the teeth.
Anyway, back to these straight lines that these guys have problems understanding. I deal with straight lines every bloody day. Over 300 meters, or 300 and something yards, you're not going to see shit.
No.
Not at all.
Mind you, I'm looking at something that if you look at the front of it, it looks straight, but if you actually look at the profile, you can see it's wibbly wobbly.
I don't like wiggly wobbly.
Is there anything like timey?
No, because it's current. It's got no timey-wimey.
Did you get your mic straightened out yet, Brian?
Man, I got to talk to a customer for a minute. I got probably about 5 minutes that I got to talk to a customer for a minute, and then I can try to get it straightened out.
Oh, okay.
But I wanted to ask you. So I've been told that when I went down the beach, that I was inadvertently, I thought I was laying out a straight line, laying a level line out, but I actually was laying out a global level line, like I was curving. And my question is do you think there's a method? Okay, like say if I was to set my first idea was to go to like the top of the beach and do a few stakes, a few benchmarks like down toward the water and just work my way down laterally at the top of the beach, keep it on shooting down toward the water, working my way over a little bit. But I'm thinking instead of doing that, I could just stand like say right next to the water. The picture I'm right next to the water, and then 100 foot away from me, parallel with the water, is well, let's say 100 feet of stake, and then 150 feet is another stake. So we'll say there's three of them, one at 50, one of them at 100, one of them at 150. Okay. Let's say I mark them all at 4 foot for a benchmark, and then let's say I just move down 50 foot, and then I line up with my instead of leapfrogging and looking back, instead of differential leveling, I just keep working my way forward. I line up with the two, and then I just lay a new third one. In other words, I keep moving 50 feet and extending that straight line out from 50 to 100 and laying a new 150. Then I move forward 50 foot, and then I line up with 50 and 100 and lay another 150 stake. And I keep doing that over and over. Would that give me a straight line and free space, basically? You think? Or do you understand what I'm saying?
It would give you a perfectly level line across that whole thing that would conform to the curvature of the Earth.
Well, I know I wasn't really asking.
I know, but that is the answer. when you just take 2 points, when you just take the 2 points, of course it's going to stay level, and it's not going to conform. It's not going to look like it's conforming to. It's going to look like it's conforming to a flat surface because you're only looking at 2 points. But if you stand at the first point and look all the way down to, let's say, 600 feet, you're going to notice it curving away from you.
600 feet, Lil. I'm only shooting 150 feet, and I'll have 3 stakes. One at 50 feet, straight in front of me. One straight in front of me at 100 feet. One straight in front of me at 150 feet. So then when I mark all them, and once I get all them marked, pick up. I'll move 50 feet, and I'll be right next to my 50-foot stake. So then my 100-foot stake will become my new 50-foot stake. You know what I'm saying? And then I'll have no 150-foot stake.
I see what you're saying. The problem here, Brian, is this. All you're doing is making a level line across a point-to-point surface. And 150 feet compared to 69 miles is how much?
A lot.
150 feet is comparable to 69 miles? So
the long and short of it is,
when you build something only 150 feet and 1 degree of curvature is 69 miles, you're only building something like probably, I'm going to guesstimate at 75 100,000ths of 1 degree. So how are you supposed to look down that and notice curvature at 150 feet?
the long and short of it is, each time you reestablish your next station for taking a measurement, you're not differentiating between a flat Earth and a globe Earth. You're creating a segmented curve. So you can't use it for this determination, because the assertion is that the vector of down changes with each of those stations.
That's
So
the
you have to have
problem.
something that isolates that from your measurement.
That's the problem. Each time you move an auto level, it's going to reorient itself in terms of gravity.
Yeah, but that's why I came up. That's why I'm throwing this idea out there, because I don't think gravity or what's underneath it matters too much. As long as I'm lining up out 50 feet and 100 feet, as long as I've got them two lined up, I should project some type of straight line out in front of me if I keep doing it. You know? I mean, can you think of a better way to lay out a straight line in free space, 2 miles, without one giant line?
Observe over the whole range.
No.
You can do that, but you'll have to have different lengths of stick, because to have them all equal in height, going down the entire line, you're going to have different lengths, like George did on his survey. His last stick was super high compared to his first one.
You need to set your datum point and run your measurements all from that one position. Before you even think of anything else, are you going over a level surface or not?
Yeah,
because hang on, Liam. Say you run a string line 500 meters or 500 yards, right? You think that the ground you're on is flat. You'll get a tape measure and measure it from the ground to that string, right? You'll need to use a laser to level the string, so it'll be a horizontal plane. I guarantee you that the measurements across that string will be different at like every 100 meters.
Yeah, that's what
Not
I'm
worried
saying.
about rebound, man.
He's using will be a different length to beat level, right? Is that kind of what you're saying, Davros?
Yeah. But it also depends on what you would do. Is you would have like meter concreting pins or something, which you knock into the ground, or star droppers or whatever. You run one line at like 900 millimeters above the ground, run another one at 300. Right? Keep them parallel, and then look underneath, and you'll see that at the end you've got a drop. That's by using strings and sticks.
All right, your phone's going off, Brian. You need to go on mute because you're hot micing it. So, if we were to do what Brian's talking about and go every 50 feet, what do you think that from, say, like the length of the first stick is, let's say, 60 centimeters tall? What do you think the length difference will be between the first stick and the second stick 50 meters away?
Well, here's your biggest issue. Something 50 feet long is either going to sag or bend at one end.
No, I'm talking about the post you put in the ground. So the first post you put, the total length is 60 meters, or 60 centimeters. And you go 50 meters and you have another post. How much longer is that post going to be than 60 meters?
That would depend if it's... Well, that would depend if the ground is level. Because if it's not, it'll go lower. One will be higher than the other. If you keep it, like, say you got your sticks and you mark them at 60 centimeters, and you knock them into the ground to set 60 centimeters over that 50-meter distance, what are you going to use to look over the top and to check that it's level? That's right, you would put a third one 50 meters away from the second one.
Right, but I'm surely talking about measuring the length of the posts.
Yeah, that's what I mean. So have a 90 centimeter post, knock it in 30 centimeters into the ground, right? So it sticks out 60 centimeters, right? Use this as your leveling. I mean, anyone could do this.
I guarantee you that going 50 meters, or 50 meters probably isn't far enough to make it like go from, so you have the 90 centimeter long stick. Oh, you dropped out. Are you still there?
I think 500 feet is like, when you start doing reciprocal zenith angles. Before that, it's like too fine a measurement to really, it's within the margin of this instrument.
Yeah, that's what I'm talking about. Like, if you were to measure the length of a 90 meter or 90 centimeter stick, put it 30 centimeters in the ground, and use that as your baseline of the thing Brian's talking about. The second post you do, how much longer than 90 centimeters is that going to be to make it level at 60 centimeters above the ground? If the ground is level. Does anyone know? Do you have any idea, Blue, how much longer the stick would have to be, or the post?
I can work it out. I could work it out, but it's a tiny number.
Yeah, it's not like it's going to be like a whole 5 centimeters longer. I don't think at 50 meters.
Oh, hell no.
It's 2.5 fleet parts longer.
Fractions of a millimeter, probably. Not the sort of thing that you're really going to be able to effectively measure. No, a more sensible thing to do would be to rely on modern GPS with real-time kinematic correction. And don't go a mile or 10 miles, go 100 miles. Go every 10 miles for 100 miles right around the coastline.
Yeah, but this is all magic to them, so I mean, you can't do that. It all can be done in the software for all they know. They just it's
Well,
built into the system to fake this shit.
I know, I've heard all that shit too, but if you're intent on using some optical method, you've got to extend this out way beyond a handful of meters. You've got to go to quite a number of kilometers to get enough deviation that you're really going to be able to see it.
We were dealing with rational people. We've already proven it to them.
Well, who said anything about rational people, for God's sakes?
That's just silly.
That's like the question I asked Pete earlier, and he said yes and no to a yes-no question.
Yeah, I don't. Something like Rumpus is working on, where you're looking 6 or 8 kilometers away. That stands a chance, a good chance. But you're going to need some whopping big ass targets to look at that far away. And that's the problem with. And now you've got all the refraction to deal with too. Well, these optical
I kind of like
methods.
Larry's stuff. You know, when you go from mountain to mountain, refraction is all but stabilized at standard, or somewhere less than standard. He does these measurements at 26 miles and gets reliably 1 foot accuracy. It seems like where I would do it is just high up observations.
Yeah, anything down low, and especially down low next to a body of water, is a real bad idea. I don't know of any good, reliable way that you're going to come up with measurements that mean a lot, that somebody can't complain about, is what I guess I'm saying. Hell, we all know they're going to complain no matter how you do it. I would like to see someone give us give me anyway, a logical method, a logical way that GPS could be rigged somehow or the other to not give an accurate measurement from the origin of the coordinate system it uses.
Yeah, I am absolutely of the belief that is useful with the information that comes out. More than one person.
Yeah, you kind of roboted for me that time, Moriak.
I can't think of any way you could fake that for more than one person.
That's right. You probably could for one person at one location. How do you do that? Using the same satellites for multiple locations.
And the same origin points for everybody.
Yeah.
And let's place those people 50 miles apart from each other. At least 50 miles.
I thought about this the other day. I thought about, what if you did a repeat of what Jesse Kozlowski did at Lake Pontchartrain, only do it on the Long Bridge, the one that we always talk about. But there's another one, which is I-10. It's not as long, but it's just to the east of the big long one. Do it on both of them simultaneously. Now, tell it when the GPSs are looking at exactly the same satellites. Tell me how in the hell, if they both showed the curvature, how could that have been faked?
An infinite number of transmitters, all transmitting unique information to every individual.
Yeah, that's essentially what you got to have.
But how do you stop the other people receiving the wrong information?
It's magic.
Because if it's being broadcast via radio, all on the same frequency, remember, you're going to have some issues.
Infinite discrimination on your antennas.
Yeah, it's kind of like when you have a 2.4 gigahertz signal, like a Wi-Fi signal, and you try to attach 200 or 300 devices to it. All of a sudden, your 100 megabits a second is going to change to like 1 megabit per second.
Yeah, and of course it only works because that's got encryption and other systems on it to prevent you necessarily receiving signals intended for other devices. Oh, and of course, most of that 2.4 gig stuff is run at really low power, so that it's got really small range.
You know, the irony in this is that at work when I'm on YouTube and someone turns on the microwave, guess what happens in my YouTube signal?
Yeah. Bye-bye.
Because that's how I get, I use a internet-based phone number for my phone. And so I use Wi-Fi to store Wi-Fi. And yeah, when the microwave turns on, the Wi-Fi signal shuts off, no matter how close or far I'm from the microwave. I can be outside, and if the microwave's on, it's going to affect my signal.
Yeah, well, that's the problem with microwaves. They don't have leak a lot of RF, don't they? I mean, not as bad as the systems that I used to work on, where okay, it was closer to the frequencies that GPS works on, 1.5 gigs, but it would leak so much in a side lobe on the antenna that if I parked my car outside of the transmitter building, every 15 seconds when the aerial rotated over the top of me, the side lobe would produce enough energy to kill the electronic fuel injection system in the car.
I mean, I could be staying right under the access point, and once the microwave turns on, I don't have connection anymore.
Yeah.
Or I should say it buffers. That's how. It doesn't completely turn me off, but it makes a buffer.
Yeah. Like I said,
it knocks the hell out of my Bluetooth, or my old Bluetooth setup. When I would get anywhere near there and my wife would turn on the microwave, it's like, oh, damn, I'm not talking on Discord anymore.
Oh my. Sorry I had to leave. I had a phone call.
Oh, glad you're back.
No one noticed.
That's all right. On 2 meter amateur
sorry.
radio, I've been driving down the freeway and lose my signal every time I go underneath a building.
Overpass.
Which flat earther was it again that actually said that GPS was standard for ground?
Oh, a number of them have done that.
Yeah, most
The
of them.
ground positioning system. Yeah, we've heard that a zillion
The only thing
times.
is, they think it's on the cell phone towers.
Yeah, I see them a lot in the ocean.
Maybe it's my fundamental misunderstanding of how cell phones work and tablets, but that's my concern with this whole ground-based satellites. Like when I crossed the Indian reservation, there are no cell phone towers within 50 miles or more of anywhere. But yet I can download an app that measures my parents' speed from the GPS that they are driving in the car.
It's really very simple. Like most cell phones or mobile phones here in the UK, you can put them into airplane mode so that you're basically cutting them off from all of the cell towers. And then I can bring up one of my GPS apps and it will tell me how many satellites I'm receiving a signal from.
Right. This is what I've told flat earthers. Crossing the Indian reservation with this app, I turn off Wi-Fi completely. I have no Wi-Fi signal. I turn it off in the settings. But yet, it's telling me the exact speed my dad's driving in his car. How's that possible?
Yep. Well, we know how that's possible.
I think maybe some of the confusion comes from the fact that there, I don't think this is universally true, but some of the cell towers are transmitting real-time kinematic correction data for the more sophisticated GPS systems. So that's something you can do with through a network, or something you can do with your own base station if you've got one. And it's just giving a correction to the satellite data. Does it in real time because it knows where it is, and it can figure out the differential between its true position and what GPS would be indicating, and that gives you an offset. And you simply tell all the other GPS receivers, hey, here's the offset. And then they correct themselves.
It just makes the margin of error smaller.
Yeah, exactly.
I believe they can also use signal trilateration from the cell tower to your phone to give you a big head start on telling the GPS where it is when you first power it up, so that it gets the location much faster than it would do otherwise.
So yeah, the unit I just I'm gonna go. The unit I just posted was my old GPS unit, and that one has no cell phone connection, no transmitters, no capability of talking to anything. You can still use those things.
On cell phones, you can't turn off the radios for the cell phone towers, right?
No, but I can tell you that this thing works independent of the cell phone network.
How do you know?
But am I correct in stating that on a telephone or on a cell phone, you cannot turn off the cell phone radios?
Yeah, you can.
In airplane mode, your transmitter is shut off.
That's transmitting for Wi-Fi though, right?
No, that's transmitting for everything.
Oh, okay.
Your Wi-Fi, your Bluetooth, the cell, the cell phone connection, the whole 9 yards.
Yeah, you're cutting yourself off from everything.
Mayok, since when you had it?
It becomes a receiver only.
Yeah, airplane mode shuts off everything.
Since when you had it, Moyak?
You what?
Since when you had this device?
Oh, that one? I got that in like 92.
That's
Might
one of
have
the
been 94. I don't want to be
yeah,
lying.
that's an early one.
You didn't have cell phones back then?
Sure as hell did, but that had no transmitters in it.
You don't know? I didn't say it.
And I know. Shut up. And I know because I actually had a spectrum analyzer also in the car. There was no other signals coming in or from that device. There's no transmitter.
I didn't say it needs to transmit anything. It's where it gets its data from.
Really? I don't see where in the CDMA standard that signal could be embedded.
Yeah, maybe they have a special antenna just for this. In the cell tower.
It can't be a special antenna. I can see what's coming in. In fact, I wager I could characterize that antenna and show you that it only works really good around 1500 megahertz.
Yeah, I posted mine. I got the 99.9, but it's taking longer and longer and longer to get the satellites to get the position. But it still works.
Yeah, mine broke. I threw it away.
Yeah, my first airborne GPS system was a Garmin GNC 250, and it on power up, it might take that thing 5 minutes to find enough satellites. It would take it a while.
Mine took about 20 minutes, I think, on the very first boot up. If you left it off for several months, it would take like 20 minutes.
Well, that's true. It depended on how long it had been off. I agree with that.
Yeah, we used mine in salvage jobs if we had to go somewhere out at sea and it was kind of misty in the rubber boat with the salvage stuff. Then we could find the boat back using my handheld GPS.
As I understand it, some of them will remember the last place it was, and if you turn it back on at pretty much the same location, they can sync fairly quickly. But if you've moved significantly in the meantime, it can really bugger it up completely.
Right, like if you hop on a plane, fly to South Africa, and then turn the bastard back on, it's going to be a little bit lost.
Yeah, like in my case, it's sometimes switched on in Asia somewhere, and then somewhere in North America.
Yeah, that'd do it.
It's impressive that it can find itself. It's almost like a bunch of smart people made that system.
Yeah,
nowadays I use this GPS puck from the USB port just for my nautical program on my laptop. That works pretty fast.
The thing that's most amazing about it, though, that little white one, the unit that I had up there, that thing was terrible. Like inside the car, I would lose GPS signal all the time. Just, with it right up on the dashboard, in the window. Now, GPS units, the receive sensitivity on them must be going through the roof because I can pretty reliably get a signal inside my house almost all the time. The receive sensitivity had to improve by 6-7 dB at least. But I've been using navigation systems on my cars since 1987. That was the first system was an ETAC system that I was using. That had cassette tapes with road databases that were 30 miles long. You just changed the cassette every time you went 30 miles. Had a little cathode ray tube TV, sitting on a stick near my dashboard.
How's my mic? Anybody hear me?
Lima Charlie, good.
Lima Charlie. How's it going, Mr. Alan Evans?
Not bad.
I see Brian has deafened himself.
Yeah, well,
I was looking forward to maybe having a this time trying to have a cordial conversation as opposed to what went down yesterday. You were around. Was it you, or was it someone else? Yeah, I think it was.
Talking to me, I was away from the mic.
No, we were who was in Geo's yesterday when I was talking to Brian? I know left lane. I think left lane was there.
I was there.
Yeah. I was just
Yeah.
was in the middle of debating whether I should make another video about this subject, but I don't know if I should. I'm like in the middle of doing it, but I'm like, what's the point?
It doesn't seem to have much influence. Gives us something to talk about, though.
Yeah, yeah. Because he still seems to be confused to which clip he wants to talk about. Because if you watch his video, you can clearly see that notice that he didn't watch the entire interview. He even said he skipped through some parts, so he didn't watch the whole thing.
No,
Because
they
there's
watch
one
it
part
till
where,
they say a word that they like, and they key on that word and then stop. Listen.
yeah, yeah. Like he
Yeah,
mentions,
which go
go
ahead.
ahead. I'm sorry.
You're talking about stuck on words. Wits is stuck on non sequitur. Everything you say is non sequitur. You know.
Yeah, yeah.
Yeah.
He does
It's
that a
like,
lot,
what the
doesn't he?
fuck? Yeah.
That's a non sequitur and a straw man.
Yeah.
I love how like Travis is always saying, "Oh, that doesn't answer my question." And say, "Well, it was my best answer to your question." And it's
No,
like
he says,
seems to directly answer it.
and then he likes to say, "Now
Yeah.
listen carefully. Listen carefully."
Again.
You know what I mean? Yeah. But anyway,
If
if you
everybody
watch,
in the audience is misunderstanding you, the problem is yours.
yeah, exactly. But if you watch Brian's little video he made to try and debunk my video, he says at one part where he says they don't mention the rainbow, the rainbow cut or whatever he likes to call it, but they actually do mention it towards the end. So that just tells me he didn't watch the whole video. And then
Yeah.
the clip.
Go ahead.
Go ahead.
Finish up. Finish up. No, finish up.
No, it just tells me that he didn't watch the whole video. And then the clip that he likes to show where they're saying that there's a cut, there's music in the background, right? So that automatically tells me that he's using that part, but he didn't watch until the end where they went over the same clip again, but it was the uncut footage, and there's no music in the background. So right there it tells me he didn't watch the whole video, and he's still trying to claim that it's the uncut footage is, well, I don't know whether he's intentionally saying, or he's like deliberately being dishonest.
But the only reason I try to hold Brian to such a standard of integrity is, I mean, he puts, don't be dishonest now. Let's try to be honest here, and he's always on about honesty and calling people liars. And
Yeah,
so,
exactly.
yeah.
And that's why I'm saying, like, is he just mistaken, or is he purposely like not like leaving parts out? I wanna say that he's just mistaken, and we're just maybe talking past each other.
What did he have to leave? Well, yeah, I
He's
know that
still.
he was in while I was.
No, he's still. He's muted and deafened right now.
And I thought on Jose's, I went through it pretty thoroughly, but he kind of attacked me yesterday on Geo's, claiming that I was a liar again about the same thing.
Yeah, I don't. That gets me more than anything. I don't mind the argument but I mean the calling each other liars and all that. I mean without any cause. I mean it's just like a knee-jerk response. Somebody says something you don't like or is against your narrative, then they're a liar. You know, regardless. I was talking about non sequitur, just a perfect example. We were talking about how much of the laser light that we shoot at the moon gets reflected back, and I said, well, how many photons are sent? Well, that was Witt's response was non sequitur. You know, I'm like, what the fuck you mean it's non sequitur?
Yeah, yeah.
What's non sequitur about that?
Yeah, nothing. I mean, it's something you need to know.
Yeah, that's at the very heart of the issue.
There's a whole lot of meters on the moon, all reflecting 2,000 watts of energy deficient. Or 7%.
I think he was trying to propose some sort of test where you can shoot radio waves across the surface of the Earth, and if you shoot them in a straight line, or I don't know, and if they hit a target, then that would debunk the globe.
Okay, I'm having a problem with all this non sequitur bullshit that comes out of their mouths. Yes, I'm swearing. How are we using a different example for the example you're bringing when we're talking about light?
Well, we're not.
Please explain.
Yeah.
But then what's a laser?
Oh, well, that's a
Lasers are
non
special.
They're not.
Yeah, that's special
Was it
light.
we're talking about laser, or we're talking about radar waves, which is a form of light, right?
Oh,
Yeah.
All right.
Jeez, don't get into radar. You'll get Alan on a rant.
A lot lower frequency, but yes, both electromagnetic waves.
Yeah, I mean,
Oh.
do we want to talk gigahertz or terahertz?
Oh, we want to talk picohertz, mate.
No,
What
we
about
don't.
Google Hertz? Well, there is such thing as Google Hertz. You know why? Because when these flat earthers Google the right words, it hurts.
Oh, no.
Well, Witz's test was proposing that the same radio waves we shoot to the moon, if we were to shoot them on the surface of the Earth, and they hit a target 2,000 miles away, that would debunk the globe.
Well, it depends what frequency you want to use to
Right.
to run your radar. Because remember,
but if they were the same frequency as the ones that we shoot to the moon.
yeah, what frequency are you going to use? Because you've got lots
Wouldn't
of
it
choice.
be something above 140 something hertz?
I mean, if you're going to use something in a sensible frequency range, from say around 3 gig, say 2.4 to 3 gigahertz, because that's sensible frequencies, because we use it all the time for lots of things. You aren't going to be able to see anything on Earth 2,000 miles away with a ground-based radar.
Right, because it's going to go straight through the ionosphere, correct?
Because it will go, well, even if you fire it locally horizontally at the transmitter, by the time that gets to 300 nautical, less than 300 miles away, that beam will be above the Kármán line.
Right.
Because
and I understand that, but he's saying, what if that happened and it still hit its target? And we're like, okay, but that wouldn't happen.
It can't. It wouldn't happen. It can't happen. It doesn't happen.
Exactly.
It didn't happen every time I tried it for 6 years.
If you do it with the moon bounce.
And I did it every year for 6 years with, not with the moon bounce, but with the,
Yeah, I'm just saying though, when they start transmitting and then listen, they're going to say they received it.
Checking for targets on the Earth by firing it out, actually firing it up at 1 degree, but because you wouldn't fire a radar horizontally because you get too much crap come back off the surface in close.
Right.
So you point it up just a little bit, 1 degree. But you know, at 200 miles, the difference with a 1 degree tilt on your boss, the bottom of the being tilted up at half a degree, because I'm talking about a beam that's 1 degree high, that's got the middle point 1 degree wide, being pointed up at 1 degree, so the bottom of your beam slopes up at half a degree. Okay. At 200 miles, the difference between what you should see on a surface that is essentially flat with terrain and what you would see on a spheroidal surface of the generally accepted radius of 6370 kilometers is around 7,000 meters. You should be able to see any target above 300, but above 3,000 meters at 200 miles. Unfortunately, the best we can manage at that distance is 10,000 meters. And that pretty much exactly conforms with 6370 on a spheroidal surface, at least out to those distances from my present location. And I did those tests every week because it was one of my bloody jobs.
Ladies and gentlemen, that was the fairy penguin.
Yes, that was the fairy penguin. And very proud to be a fairy penguin, I might add.
Well, you should come for a trip down to Australia, go to Phillip Island, you'll see fairy penguins.
Yeah. Well, you know, my 5G vaccine upgrade that I've now had, I can communicate with them remotely anyway, so it's not too much of a problem.
Oh, well, launch the missiles. Okay.
How else do you think we control them while they're guarding the ice wall?
Yeah, true. They are on long reconnaissance missions on the daily. Do you know, it's been 2.5 years since Chemo said he'd set up a GoFundMe to go to fucking Antarctica with Hannah.
I'd go to Antarctica tomorrow if I could.
Oh, yeah, but he said 2 years. It only costs about 10 grand.
I know. I just find it mildly embarrassing that I'd have to set up a GoFundMe to fund me to go on a holiday that I'd absolutely love. I mean, you know, that just seems wrong, really.
He would prove it to himself and the rest of them and have a holiday. Because you get to go down to Uruguay, jump on a boat, go across the little bit of water, and you're there.
Yeah. Hey, can I come to Enfield or Australia and do the boat trip from there? I know it's a lot further on the boat, and I don't really like boats, but
you have to wait till summer. So they go from Uruguay during the winter.
Okay.
Only because there's more icebergs happening.
Yeah. I don't want icebergs. Icebergs are bad. Although, of course, you can find them with radar these days. It makes life a lot easier, doesn't it?
Except for those secret ones that you can't see, you know.
I'd love to go watch those icebergs roll over. And glaciers calving. I'd love to go see that.
That would be a trip for sure. Of course, you can't do that because the armed penguins would stop you.
Hey, look.
Shoot you in the head.
Yeah.
But Blue, it's all right. We can go. I'll just deactivate the penguins. Told you. I've got wireless connection with them now. It's easy.
Oh, okay.
You know, because I'm a fairy penguin.
As long as we put those things out of commission, I'm okay with it.
Well, it's not so much we put them out of commission. They're on our side.
Yeah, maybe we can book tickets on that Flat Earth cruise they tried to arrange 2 years ago.
Yeah, I was hoping Brian would join back up, but I'm not sure if he's going to. Don't know what he's off doing at the moment.
Want me to get Pete?
But the yeah, I thought the assault Bev laid on FE Dogma last night was pretty disgusting, and I've avoided showing any of that today. I don't really see the point in it. But that poor guy is so confused. To begin with, he couldn't even figure out the elevations. He couldn't figure out that one of those arms starts low, climbs up to the center station, and then continues to climb to the end of the other arm. He couldn't even figure that out from the elevations. Somebody had to point it out to him.
But he's got logic.
Well, something went wrong. Something went tragically wrong with the logic.
Yeah, I started watching for a few minutes. I was actually gonna I tried joining his Discord server, but I guess you have to do someone else has to like give you rights or something.
Yeah.
I don't know why. I have no idea why I wanted to do that, but for some reason, I heard him say something about water levels, and I kind of wanted to troll him a little bit and drop that water level picture that I've been showing everywhere from the one from Jesse. I love that one.
Yeah, that's a good picture.
Wanted to see his thoughts on that. I'm pretty sure he'll have some. He'll probably disagree with it. Don't know why. I mean, it's a water level.
Oh, I'm sure he'd disagree somehow or the other.
Oh, it's probably not long enough. Has to be like a 1 or 2 mile long water level.
Oh, well, this was funny. I've got up on the screen right now what FE Dogma did to analyze the elevation data. And he took the very low end of the northwest arm, and it has an elevation of 529.63 feet. So he said, okay, what happens if we have a horizontal line tangent at that point, that 529.63? Okay, 529.63 is on a sphere a constant elevation. So he draws a curve, which is the level line at 529.63. But then he goes in 4 locations and gets the actual measured elevation, right? And clearly, you see a 4.15 foot change in elevation. At the and the other end would be the center point of the LIGO installation. That's the apex of the 2 tubes, right? Okay. That matches, if that is a straight line, the LIGO tube is a straight line as we know it is, then that shows you the Earth curvature very, very nicely. Then he moved to the center point, which is this bottom sketch. Though this is part of Bev's diatribe last night. Moves to the center point and establishes another horizontal line, starting at that elevation, and repeats the process. And once again, by the time you get to the end of that southwest arm, you're 4.15 feet out of whack again. Only it conforms exactly to the curvature of the Earth. Now, Bev, in his infinite wisdom, tried to say that you've got a line with two tangent points.
Wow.
Let that sink in for a second.
Of course.
He tried to claim that F.E. Dogma had created a line with two tangent points. Jesus. No, you idiot. That is two separate lines with two different tangent points at two different elevations. You need the IQ.
Can you hear me, Blue?
Yeah. Yeah, I hear you, Brian.
Hey, is there a splitter? Is there a mirror that divides a beam, or is it its own? Is it each arm have its own beam of light?
No, it's an interferometer. It's got a splitter there in the middle of it, at the laser end of it. Like any interferometer,
Like
you got to start with a single beam. You got to start with a single beam, split it, and bring it back together at the end to see the interference pattern.
Right. So you're gonna have a hard time splitting that beam if you have two tangents, ain't you?
No, that's the point. You don't have two tangents. The beams are the tubes are.
No. I meant two tangents on a tangent for each line. I meant.
Well, it's just a way of analyzing the elevation. That's all. In reality, those 2 points are that center point is the same. You could have, if he would have analyzed it from the center and worked both directions, you could have done the same thing.
Didn't me and you go over this? We established that the tangent was like in the center point of the northwest arm.
Well, at Livingston, I think it probably is close to there. At Hanford, not at all. I'm not sure where it is at Hanford. It's somewhere in that triangle, according to the documentation. The triangle formed by the two legs, but we don't know exactly where their tangent point is. These are just references.
Is it possible? Sorry, I didn't know if I heard you right. Did you say there was there's a tangent for each one of these lines, or is it just one common tangent? I haven't even looked at that one yet.
Well, the two arms sit in a plane, right? The two arms would define a plane, and that plane is tangent at some point in that triangle formed by the two arms. We don't know exactly where that point is. But when F.E. Dogma did this, he just established a fictitious horizontal line at a tangent point for that particular elevation. That's all he did. This is just for analysis purposes. That's not saying that the interferometer is tangent at that point. That's just a way to analyze the data. That's all.
Yeah, I didn't catch all of that, but he made it seem like one of the arms was sloping.
They both are.
They're both sloping on the same horizontal plane, basically. Then is that what you're saying?
They're both they both slope. The northwest arm slopes from its end up to the center point, the point where the two arms are connected, and then the southwest arm slopes from that center point up to the end of it. So the entire thing slopes up from the total from the two corners, right? The ends of both the arms. There's an 8-foot difference in elevation. At the center point, there's 4 feet.
That's where I have my problem, man. That's where, in my head I had a problem with if they're sloping in different directions, it's going to be tough to split the beam, ain't it?
You can't slope them in different directions. They're
Not saying they couldn't do it, but it just seemed.
Right.
They're just connected. You've got two lines effectively forming an angle right there. You can't slope one with regard to the other one in terms of the plane that it defines.
Right. What does the beam care about sloping?
It doesn't.
All it cares is that it has a straight path. It can go. That's it.
Right.
Yeah, as long as they're on the same path, yeah, that makes sense to me. But if they're not, then yeah, it seemed to be not impossible, but difficult.
What?
They can't not be though, Brian. You've got two tubes joined together at a common point. That defines a plane. Now that plane could be lying in any orientation you care to mention. Any direction. It makes no difference. Think about it.
Yeah, like I said, if they're on the same plane, then it can all be sloping, whatever way.
Yeah.
But I was just making sure because somehow I was thinking if one of them slope, let's just say the tangent. Well, that begs the question. Okay, what about the Livingston arms where the tangent is in the middle of the northwest arm? So the other arm would have to pretty much be on that same plane. I mean, it's the same thing. They have to be wherever the tangent is. There can only be one. Wait, have you figured out a way for there to be a tangent for each arm? Each arm can't be on the same tangent, right? That's not possible, right?
They're on the same plane.
Neither one of the arms needs to be on the
Gotcha.
at the tangent point. They're just in the
Okay,
plane.
okay.
Yeah. And the plane that they define is tangent to the Earth at some point.
Yeah, I mean, I was just kind of defining the lowest point as the tangent, I guess. But okay, I see what you're saying.
Yeah. Yeah, just cut yourself a triangular shaped piece of cardboard and lay it on your globe and see what it does. And you can flip it around, move it, tilt it and cock it and do all kinds of things to it. And it'll work fine.
Sure. Long as it's on that same plane.
Yeah.
Yeah.
Brian, two lines always form a plane between them.
Right. No matter how they're oriented.
What about 3 points, though, Chuck? 3 points don't always necessarily form a plane.
2 lines.
Yeah, actually, Brian, you need 3 points to form a plane. 3 points.
Yeah, but
2 lines.
Okay, yeah.
Yeah, 2 points won't define a plane.
You're right.
2 points can only
They're
define
really
a
smart
line. That's
people,
all.
and they built this thing. They built this thing purpose-built to be on the same plane. So I mean, probably pretty much trust they did it right.
It don't matter. I mean, until I check it, I'll take it with a grain of salt until I check to see what it does up against water. But I'll let it ride for now.
Yeah, we need you
You're
to
never gonna
confirm
check.
that LIGO didn't fuck up.
Out of answer the buck.
Well, there've been
Something
a lot
makes
of
me think you're never going to check it, Brian.
We'll see.
Yeah, there've been a lot of myths associated with LIGO.
Moment that shifts me to the globe, man. I want to make sure I got everything worked out as far as before I do it, if I do it, because to me, if they're getting there's only one problem is the size of the tube. It's even if it was by the globe Earth spec, you could still reach the end of the tube. I think there's enough play in there where you could still reach the end, even if there was a curve in it. But I got to double check that. I haven't, that was just my rough estimate. It seemed like there wasn't enough slope in the tube anyway to prevent it from reaching to each end. Either way.
Well, there have been a number of myths associated with LIGO, mostly created by people like Bev and S.E. Montreal. And a lot of it starts with this concept that somehow or the other those mirrors, the surface of the reflecting surface of the mirrors themselves, hang vertically, absolutely perfectly parallel with the gravity vector, which is not true. Those tubes do slope. One of them at Livingston and both of them at Hanford have a 4-foot slope over that 2.25 miles. So the thing is, even though they're hanging like like a pendulum, you can still turn the surface of the mirror slightly, and that's all it takes is very slightly, to aim the thing at down the axis of the tube. So that's a big point of confusion that I blame SE and Bev and people like that for. They didn't bother to find out. They just assumed
Sure, they'd have
that
to
it was
set it
built
up.
level.
I mean, I'm sure they'd have to fine tune it, when they put the thing together, regardless.
Hell yeah. Yeah, they just made the silly assumption that it had to be level. Well, no, it didn't. It didn't make any difference as long as they wanted it right angles, but one tube could be on the ground and the other one could be standing straight up in the air for all that matters. For all anybody cares, except that would just be a stupid way of doing it. Now you got to build a 2.5 mile tall stair tower to get up to the damn thing. Of course, you're not going to do that. You're going to lay it on the ground. But level has nothing to do with its ability to function. Nothing at all.
Well, we could just make it just a regular ladder.
Yeah. I've climbed an 800-foot stack before. No, you don't want to do that.
No, I don't. But I don't know, man. It seems like as far as maybe for a second, if let's say this, just hypothetically speaking, if the Earth is flat, let's say the tubes didn't line up with the water, but the Earth was flat and the water was flat. It's not that much, man. In the middle, I don't think. Wouldn't they still be able to reach the end? Wouldn't they be able to bounce their back, even if the Earth was flat with them size tubes?
Well, if you set both ends at the same elevation, the center is about a foot lower, right? The elevations on the ends would be high, and that's what you see at Livingston on that arm that's on the whichever side that is. I forget what their nomenclature is now, but yeah, it would only be about a foot. And yeah, you'd see the other end of the tube. It's a 4-foot diameter tube. It would just be off center in the middle by 1 foot.
Yeah, they would need some prism in the middle.
But that thing is bouncing back and forth 300 times.
You'd know, though. Even if you could make it work, you'd probably know by where you had to set the mirror. Or you'd have a good idea of it anyway.
Yeah. Yeah, in all likelihood, yes. I don't think anybody says. I'm not sure how critical it is that the beams stay exactly coaxial in the middle of that tube. I'm not sure how critical that is or why it would be.
I just wanted to check the water. I didn't want to bother with anybody inside. I didn't want to get nowhere near the thing, or I didn't want to rock the boat any at all. I just wanted to test water at the beginning, at the middle, and at the end. I didn't even necessarily need connecting water. I mean, we agreed that the groundwater, we let it settle, would probably be pretty accurate in that area especially. But so if I tested the water with the beginning and up against the concrete pad, and I'd be surprised though. It would surprise me if it showed a lower spot in the middle, but it would probably change the way I think a little bit. But not 100% sure it'd prove anything for me, but I don't know. It might.
Actually, I don't think it's possible. It would reflect from the same points all the time because it would come back to the splitter, and they want it back in the splitter or the joiner after they bounced 400 times.
I'd be tickled to see a straight line with a fucking where water collects in the middle, man. That's one thing I'm picturing in my head. It's just like it doesn't work for me, man. When I picture bridges and shit with water collecting in the center, like a straight bridge, with water flowing down toward the middle, it doesn't sit right with me, man. But seeing it might help change the way I think. It might not, man. I'm just saying it. Seeing a straight line collect water in the middle, doesn't that fuck with y'all's intuition a little bit, man? If nothing else.
Not really for me.
Well, it's something I had to think about, but I don't have a problem with it.
See, to me, it boils down to the problem. Like if you have the water and the straight line, you got the water and the right above it, you have the straight line. So you ask yourself, which one is straight? Okay, if the water is curved and the line is straight, no, I did it like this: the bottom of the little bay, and the water on top of the bay. So the bay, is it the bay that's flat, or is it the water that's flat? Because one of them has to be flat. And this is going by a scenario where the little bay is like 10 miles and it's or 20 miles long, and it's like 66 feet deep in the middle with a perfect transition, like a in a perfect world, just a hypothetical thought experiment. So then you're thinking, so on a globe, the bottom of the bay would be a perfectly straight line, and so it'd be deeper in the middle. So you ask yourself, okay, is the water on top a straight line, or is the bottom the straight line? Crazy little thought.
Oh yeah, get closer to your mic.
You're robot in bed, Moya. Boing, boing, boing. Boing.
I'm glad it
So
wasn't.
if you had an 8-inch pipe, 2 miles long, tangent at the middle, the pipe would be full in the middle and just dripping out the ends. Would that be right?
Oh, yeah. If it's 2 miles long, yeah.
So in your world, a straight pipe. So if we cut it in half, like a long ways, where it's just half a pipe, basically just a bowl, a long ass bowl.
Okay.
And it'd be full in the middle, and it'd be dripping out like empty at the very end, basically.
Yeah, that's what it would do.
I want an example of that, man. I want a visual example of that.
Unfortunately, nobody's going to spend the millions and millions of dollars it would take to do that for no reason. When we know
We got to be able, we could create something like that on a budget, man.
Yeah, that seems like an unrealistic expectation of science.
Oh, you want the budget version? I might get it down to $5 million. How's that?
No, man, I think me and you have a different definition of budget.
I know what that kind of construction would cost. Unfortunately, it
20,000,
wouldn't
Brian?
be cheap.
20,000 is kind of standard flat Earth budget.
Flat Earth budget. But yeah, that's basically no budget at all, man. When I went to do my 1 mile preliminary test, man, I bought the 1 mile line and it's strong. I still got it, but nobody put in. Man, Brandon and Travis put in, and I was just trying to get some people to pitch in to get a little help out there. And And I probably could have. I could have financed. I went out there and tried to do it anyway, but I couldn't. I didn't have enough help. But it just kind of it aggravated me because nobody. We talked about this shit for months, and I go to do it. Just a preliminary to see if it was even worth doing the 3 mile, to make sure the 1 mile would work. And nobody would even pitch in any. I couldn't believe it, dude. I'm like, dude, we talk about this shit every night, and nobody fucking pitch in a fucking dollar. Dude,
Right.
it's crazy.
Brian, what were you trying to do? I don't understand to this day.
I wanted to check the buoyancy of the line to see what it did underwater.
To
Yeah,
check
you
the
wrote.
buoyancy of the line, you just need to throw it in the water.
No, it's because if you pull it taut,
Why do I
then
need
the
to pull
line
it
would
tight?
sink below the water.
Well, I want to test his buoyancy before I pull it tight to see if it sinks or it floats.
Am I right about that, Brian?
Well,
You pull it
but
tight,
well,
it would sink.
well, you pull it tight, and it sinks under the water. Did it sink because you pulled it tight, or did it sink because it's not buoyant?
No, it would sink because there's a curve in the water. We're pulling
How
it.
do you know? Maybe it's not buoyant. That's the first thing you need to check. You take it
Yeah.
out of this plastic thing it's on and throw it in the water. Does it
No.
sink or does it float?
The idea of that test was to use that line as your straight standard.
Like a
So
tangent.
yes, you have to pull it tight. But Brian's idea was to use a line with neutral buoyancy. What you don't want it to do is either sink or float. You want it to stay where you put it.
But there would always be, I think, no matter what, there would always be sag in it.
Yeah.
Why?
You can't pull the sag out of a line.
Yeah, but it got it. Is when I did it
But-
over land, it went way far, like over 470 feet. The sag was way less than I thought it would be. I thought it would be like the construction line, where when I pulled it tight over 100 feet, it gives a little sag. I mean,
Yeah,
it
but
was dead straight over hundreds of feet. So I figured it was worth trying to shoot water anyway.
We don't care about 100 feet. What about a mile?
Yeah, longer and longer you have it, it's going to be heavier. And
Yeah, the
it's gonna
sag
have
goes. The sag goes up by the square of the distance, if I remember my engineering correctly.
And it'll
But you-
snap before anything.
Yeah, I don't care what it is. You absolutely cannot pull the sag out of a line. There is no way of doing it unless the line has no mass or you've got infinite tension. One of those two things has to be true.
Yeah. Just go
Oh.
look at catenary sag.
Or that it's naturally buoyant.
Right. So if it was buoyant, then it would be reverse sag. You know what I'm saying? So I figured somewhere in there's a happy medium where it could be sagging a little bit. It just couldn't be sagging more than the perimeters of the test, so we could get see which way it gestures. There would be a little bit of consideration for a sag or buoyancy, as if we could get it close enough. I think if we tried hard enough, we could do it, man. Even if it took some extra effort, I feel like it's possible. I don't know.
Well, I know you've pulled a construction line or tried to pull one a long distance, right? Go out sometime and
I have. It doesn't work.
And pull one 200 feet, let's say. Try to pull the sag out of it. You can't. But
No, you can't.
While you've got it under as much tension as you can put on it, go to the center of the thing and see how you just barely have to touch it to cause it to deflect 3 or 4 inches. It takes
Yeah,
almost
it's still
no
loose.
force. Yeah.
You're right. Yeah, I did a lot stretching these lines.
Oh yeah.
I really couldn't believe though how straight fishing line would go and just how far. I was really shocked that it goes so many hundreds of feet straight as an arrow, damn near. I did put the instrument on it and it was sagging a few inches, but that was an error. It looked straight as an arrow, so I was like, man, let me get my instrument and see. And yeah, it was sagging a few inches, but that's before I even broke it. Who's to say I couldn't have got it down even a little less than that? But and that was just with line that I had sitting around with like 50. I think I tried 50, 30, and 15 pound. But I don't know, man. It just seems like it's worth talking about. It's worth trying. I ain't gave up the idea completely. It just aggravated me that nobody on the flat earth side wanted to pitch in nothing, man, except Brandon and Travis. That's it. Nobody else. We talked about the shit, like I
Well,
said, for
I'll
months.
pitch in. I'll pitch in. I just need a good plan for the tests you're going to do.
Fair
It's
enough.
not worth to throw money on something that is doomed from the beginning.
Yeah, that's why I already got the listen, I already have the 1 mile line and I'm gonna try it. I might do it this summer, but you know what? Talking about it makes me want to do it more, but I'll make sure it's even worth trying. Like I said, if I can get this 1 mile line out and pull tight where it's where if I can get it buoyant enough in the perimeters of the test, then I'll let y'all know whether it's worth trying to ramp it up, a mile or two past that. I'll try that one first and see, and I'll record it too, man.
Shout out to David Lee for $2 who says, Brian, come to Annapolis this summer. I don't know what that's about, but you've been invited to Annapolis apparently.
Where is that? In New York or something? Or is that in Indiana or what? Wait, that's the capital of that's the freaking
Annapolis, that's in Maryland. It's
Yeah.
the station of
Naval
the
Academy.
United States Navy
That's the Naval Academy. Yeah.
Academy.
In Maryland. That's right.
Even this
well,
British.
I appreciate the invite, man. I'll talk it over with my wife.
That's a road trip.
Yeah. And Brian, I know we spoke about this before, and you said you would look into it, but I'm going to guess you didn't. You wanting to make something that's straight and stick it out and see how far it will go. Well, I've done this test. I've done this test with radio waves that have essentially zero standard refraction. So they go straight. And they go straight for 300 miles.
What'd you say? Zero what refraction?
Zero standard refraction. So the atmospheric refraction you get with visible light is essentially zero for the radio waves because the wavelength is a couple of thousand times longer, and wavelength is important with refraction. So yeah, and I've done the tests out to 300 miles, but mostly out to 200 miles. Mostly it's 200 miles because the target that we're bouncing the light back off of to see, they tend to be around 10,000 meters, 30,000 feet above the surface of the ground, and that we can never see them past that distance. Now, if the surface over which we were sending these radio waves out was essentially flat with terrain, we should see everything that's above 3,000 meters. So that's a 7,000 meter difference, and we never see. We always see them at 10,000 meters. We don't see them at 3.
Well, there'd still be diffraction though, right?
No, there's no diffraction.
No diffraction, huh?
There's no diffraction, no, because there's nothing there to diffract it. And say the standard refraction is
No. You missed my point. If you're trying to do it over the ground, and you said, "Oh, the Earth ain't flat because this beam didn't make it," I'm telling you that it wouldn't make it on a flat Earth either because of diffraction.
why would diffraction be a problem? There's no edge over which it can diffract.
That's right.
Where did you try it on a flat Earth? Where did you find 200 miles of flat ground? I'm just asking.
Well, I didn't find 200 miles of not flat flat ground because I tried it on the real planet Earth, and I only ever got altitudes of targets at ranges that corresponded with the surface over which the observations were made being a spheroid of approximately 6370 kilometers radius.
Yeah, well, try it on a flat Earth. Try set up a flat Earth scenario.
Well, that's what I did. If we looked at it on a flat Earth, at 200 at 200 miles, you should see everything above 3,000 meters. And we can't see targets at 3,000 meters, or 4,000 meters, or 5,000 meters, or 6,000 meters, or 7,000 meters. They have to be at 10,000 meters for us to see them.
You tried it on a ground where you didn't have any diffraction. Like, what are you trying to say? Like, you'd had to point it up in the air.
Well, okay. We have a series of, this particular radar has a series of stacked beams 1 degree high. That bottom beam, the center of that beam is elevated at 1 degree. That means that the bottom of that beam is elevated at half a degree.
Yeah, so why would you expect to get it down low if you have it any degrees pointed up? I'm just asking.
That's why I just said because the bottom of the beam is pointing up at half a degree. That's why I said at 200 miles you would have a minimum height that you could see of 3,000 meters over a flat surface.
It'd be way more than that, dude. At half a degree over 200 miles.
Half a degree over 200 miles is 3,000 meters.
Oh, really? I didn't know. I want to check your math, but it doesn't sound right. But maybe it is. Have you already done the math?
Oh, I've already done the math. I can give you the spreadsheet if you like.
Blue, a straight line, half a degree from your starting point, over 200 miles. Well, what's your the triangle height to the opposite side?
Half degree. I don't know. Give me a second. I'll do a quick calculation for you.
3,000 meters, and it just doesn't sound right, you know. But I ain't trying to be a dick or anything, Alan. I just doesn't sound right in my head. Maybe it is right, but I just want to double check it. I'm on the road. I'm almost to where I'm going though, and I can have a better conversation with y'all.
Can I just say, Blue, that is radar miles, and a radar mile is 1.5 kilometers, not 1.6 kilometers. So it's about 180 statute miles.
Yeah, I'm guessing it's in my head, it would be.
It's 2808. meters.
2,800 meters.
2,808 meters. Yeah, half degree, 200 miles.
So what is it over 1 mile, Blue? What is it over 1 mile?
Half degree. Hold on.
I've just posted two versions of essentially the same graph in the live chat. One is basically just zoomed in compared with the other vertically, because we're really only interested in.
It's over 1 mile is 46 feet, Brian.
Thank you, man. Thank you. I'm actually pulling up. Okay, so that's still over a mile high, over 200 miles. But let me say this, Alan. Okay, if you're shooting something and you're looking at it, or from an orthographic view, if you're 100 feet, let's say if it's on the ground or 50 foot above the ground, if there's something 50 miles away that's 101 feet above the ground, it's in essence going to block the signal. I mean, maybe not 101 feet, but you know what I'm saying. You got to make sure you got a perfectly clear path. I mean, did you?
Yeah, okay.
Where'd you do it?
Brian, I happen to live on one of the flattest parts of England. I'm only about 50 miles from a certain place called the Bedford Levels. Okay, the radar station was about 10 to 15 miles from the coast, with literally nothing in the way, with no hills in the way at all, and then the sea. So we're basically looking at observations across the sea with no terrain in the way, because the radar's on the top of what passes for a hill round here, a hill that's 20 meters above sea level. And round here, that's a bloody mountain.
I tell you what, man, they when I was looking into radar, they they were saying that the reason that the radar was going so far because excuse me, they had Doppler radar here in Florida. I haven't found it. I don't know if they're still using the same station, but so it'd shoot like down to through the Keys and stuff, and I think that tower for that, so it's Lauderdale or whatever, down through the Keys, and then it went or it might have been on the coast of Miami, something. But anyway, it went on its weather, and Mr. Drive and Survive brought that as a point of like radar. He'd give the tower height and all that. How could it be showing the weather so far away? And they said over water it would reflect or it would hug the earth or whatever. But then we looked it up, and it extended out past Cuba. So the radar would have had to have went over the water and also went over land, and then still extended its signal out past Cuba. So the water excuse was invalid. I wish I could remember exactly the distances and all that stuff, but I just remember that the water was the excuse of why it went so far, but it also went over land. You remember anything about
that? I can remember somebody talking a load of bollocks about it. Yeah, I can't remember exactly what it was, but basically the claims are not going to hold water because
let's say this, like the radio wave,
the radio will not support it.
The radio waves, like that Marconi bounced, okay, are the ones when they determined the ionosphere or whatever, they're saying that it was getting caught in like tropodrafts or something, troposphere drafts, something like that. but they're saying it was kind of in the ionosphere and whatnot. And every excuse they gave of why it went so far, the same beam, same radio signals won't make it over like the Rocky Mountains. Like, okay, so this beam is supposed to be bouncing off the troposphere and making it, but that same beam won't make it through the Rocky Mountains. That would at least lead somebody to believe that it's the potential of the fact that the mountains are blocking it, and that the ionosphere ain't got shit to do with it.
Actually, if you want to go there, that's fine. But Marconi's original wireless telegraphy system used a spark gap transmitter that transmitted over a very wide frequency band.
It was like 200 kilohertz or something.
Even lower than that. But
it's transmitting at such a low frequency that it does a thing called ground wave propagation.
I know what he did, Alan. I know what he did. He took and he slapped a whale on the he took and slapped the whale on the ass, and the whale said,
Brian, let's just be sensible about this and get the correct information out there. I know you don't like it, but
I'm just joking, man. I'm just joking. I'm trying not to get all personal and shit. I thought that was funny. Sorry, man.
The reason why Marconi's radio was able to get to where it was going was because he was using ground wave propagation. Ground wave propagation relies on the fact that the capacitance of the surface, especially water, is such that it slows the signal front down that is in contact with the surface and allows the radio wave to literally follow the surface of the Earth. And it will do that for a very long distance.
Yeah.
All the way across the Atlantic.
But that's very low frequency.
Cuba, it should be able to go over Cuba though, and then pick back up where it left off, back in the Atlantic though, right?
Huh?
This worked from I can't remember whether he was doing it from Ireland or from
Scotland. It was from Scotland, I believe. Somewhere in Massachusetts to somewhere in Scotland, as I recall.
Okay. Yeah, and it's very, very slow data rates, as it has to be, in order for this to work.
So that signal he was using wasn't straight line signal.
It could, because as I say, if you pick the right see, that's the thing. That's why I said you have to pick the right frequency. If you pick a really low frequency, you get ground wave propagation. It will literally follow the curve of the Earth. If you go up some, you get frequencies where it essentially travels in straight lines. However, it won't pass through the ionosphere. So when it gets to the ionosphere, it effectively gets reflected back down and you get skip. Now, the distances that you can be heard at for skip depend very much on the weather, on the they call it weather conditions, but it's it's mostly what the sun's doing with cosmic rays and stuff to affect how strong the reflection you get on the ionosphere is. So of course sometimes you will get you'll be able to pick a signal up at a particular distance, and other times if there's skip, there won't be any skip at all, or the skip will be different distances, and it will actually reflect off the ionosphere, come back down, reflect off the surface of the Earth, and it can keep going, and you can actually
Okay,
get.
let me pick your brain. Let me pick your brain a little bit. So the same signals that can curve around the Earth can also bounce off the ionosphere. So if we aimed it low, it would have a chance of making it further, and if we aimed it high, it could bounce. Wait.
No.
Is it bouncing off the water or is it hugging the water? Wait. You see where I'm my line of questioning. Can you fill me in on that? And also like the range of frequencies, like not exactly, but like roughly.
Okay, ground wave propagation is in the single digits of kilohertz. So up to maybe 10 kilohertz mostly, for really long range ground wave propagation. You do get ground wave propagation occurring to a degree up to a couple of hundred megahertz, but that won't go nearly so far. Whereas
Gotcha.
when you get into the megahertz and the tens of megahertz, that's where you tend to get skip.
Wait. We can curve megahertz signals too.
No, you tend not to. You get a degree of ground wave propagation in megahertz, but not very much, because that's not what it tends to want to do.
What are sonar? What's sonar?
Sonar isn't sonar isn't radio. Sonar is acoustical.
Audio, totally incomplete.
Yeah.
Okay.
It's audio. It's sound waves through water. Yeah, because water is actually really good at propagating sound waves.
Right. Okay, so all right. So, do you know about where the cutoff is to where Wait a minute. Did you say that the ground what waves will make it through the ionosphere? What frequency? Roughly.
Right. Hang on. Let me give me a minute.
You're getting up into the gigahertz.
Well,
yeah, no rush.
No, you can make it through the ionosphere at much lower than that. In the 50 megahertz range for sure.
Yeah, there's all sorts of gaps in and things. It's not a below this frequency it does that, between this frequency and this frequency it does this, above that frequency it does that. There's various windows that do different things.
And they do different things from day to day, and sometimes from minute to minute. But
yeah.
For example, right now the International Space Station has got an amateur radio repeater station on it. The uplink is 144 megahertz. The downlink is about 440 megahertz. So there's no problem transmitting through the ionosphere at 144 megahertz.
Wait, what's the downlink?
Downlink's 440, or in that range, around in there somewhere. Uplink's 144.
And the amateur radio?
It's amateur 2 meter. Yeah, right. Yeah, it's strictly for amateur radio.
So is there any signal in that range? That sounds like right about the range he's saying, where it kind of might curve a little bit, but so you might be able to
Oh, there are times.
The ISS like a little bit beyond Earth curve.
There are times when we get when you'll get ionospheric skip occurring at 144 megahertz. I know, I've done it. More frequently at 50 megahertz, and even more frequently when you get down in the 21 megahertz range or 14 megahertz in those amateur 20 meter and 15 meter and 10 meter bands. Below that, not so much. But the lower you go, the more prone the signal is to being acceptable for ground wave propagation. Turns out that Marconi, probably more by necessity than accident, ended up transmitting at a frequency that was very, very agreeable to ground waves. You get in that 80 kilohertz, 100 kilohertz range. That's wonderful. If you increase the frequency up to, say, 3 megahertz, you'll have a 60 dB signal loss. And 60 decibels is a shitload.
Yeah.
Right. Did Marconi, did his shit wrap around or did it bounce?
No, it was wrapped around.
Marconi's wrapped
around, so it didn't involve the ionosphere?
No. No, you can't skip 100 kilohertz signal off the ionosphere, no.
You can wrap it around.
The tropospheric scattering.
I'm sorry, say again.
I may have stepped on something.
Said something about scattering, tropospheric scattering, I think he said.
Tropospheric scatter at about 5 gigahertz. You get maybe 200 miles over the horizon.
Yeah. Under just the right conditions.
Yeah.
Well, an awful lot of power too, and using something like a 100-foot dish with a couple of megawatt signal. Yeah, you can get an awful lot of stuff.
I thought you said a lot of power.
A 100-foot dish with a feed ordnance putting out a few megawatts is a lot of power.
No, that's not a lot of power. A 60-foot by 22-foot dish that you're feeding 60 megawatts into is a lot of power.
All I know is we had, oh God, what were they called? Klystron generators that were putting out an awful lot of energy.
Yeah.
Yeah, that's the thing. The radar system I worked on had 12 5-megawatt Klystron power amplifiers. To get the power up to where it needed to be.
Yeah. And now you're talking about Klystrons the size of a refrigerator.
Now I know where to find those photographs. I'll stick the photograph of it in the Discord.
Would you tap off some of that with a waveguide and just run it over to the kitchen microwave?
Sure.
You could try it if you want to, just don't stand anywhere near.
And do your popcorn in 1 second.
Or less.
And make sure you don't have any chocolate bars sitting around either.
There you go. There's the Klystron in the rack. The Klystron is 7 feet tall.
Let me see if I can figure out how to put it on YouTube.
And that.
Yeah, there it is.
Yeah, and that's three of the waveguide racks.
Hey, let me ask Alan something else. Oops, sorry.
And the last one, that's the antenna, the big elliptical dish, not the one in the one in the front is for the secondary surveillance radar.
Alan,
Yeah,
what
now
was the
put that on a truck so you can transport.
What was the height that you picked up the signal? You said at 3,000 meters you weren't able to pick it up. But what height were you able to pick it up?
we at maximum range, if you were 56,000, we could see any aircraft in service at the time that we were operating the radar. We could see any aircraft in service that was capable of reaching 56,000 feet at 300 radar miles, which is 450 kilometers.
Could you see something at like at 25,000 feet?
Yeah, but only if it was at about 150 miles. Because the altitude, the what we call the thing we call the radar horizon, you know, it changes with the altitude changes with range, you know, because the Earth is definitely a sphere of roughly 6370 kilometers radius.
So over 150 miles, you were able to detect 25,000 foot altitude.
Yeah, about that. Yeah, sorry, I'm not actually pulling the graph up.
So approximately, I got you.
So yeah, let me fire that up. So
that's enough proof for you that Earth's a sphere.
Well, let's just say I wouldn't have been able to do my job for 9 years if I wasn't. And you also have to understand that I was a technician. I wasn't an operator. Okay, I was a technician. My job was
Let me
maintaining.
ask one more question, man.
My job,
I understand that
stuff. Yeah, I did a course in a civilian trade school, taking you 2.5 years in 6 months, because it was the military. I did all of the experimentation. I did all of the experiments that you would do in the lab to prove this stuff works. When I did the 6 months course after the basic trade training to qualify me to work on this radar, I had to be able to understand the operation of every single circuit in the entire radar.
I believe all that, man. But let me ask you a question real quick. What would be if it wasn't for Earth curve? How far you think that particular radar would make it? What would be a limiting factor besides Earth curve, or how far you think you could have detected with that system?
With or without Earth curve, the maximum range of that radar is 450 kilometers, because there's other physics and engineering that gets in the way. That means that we can't see further than that anyway. Because
how many miles is that? About 220, 250?
450 kilometers. It's what we call 300 radar miles. The radar mile is 1,500 meters. And a statute mile.
What do you mean a radar mile?
Well, okay. If you use nautical miles, so if I talk to a US Navy radar guy, and I have done, because the US Navy is really keen on using nautical miles for stuff, they have to set their systems up using 12.35 microseconds per mile, whereas we just call them radar miles, and that's 10 microseconds per mile. So it's
300 nautical miles, basically. I get it.
No, it's not 300 nautical miles. It's way less than 300 nautical miles, because a nautical mile is 1,852 meters, and a radar mile is 1,500 meters. Yeah, I'm sorry I have to work in a.
No, that's fine. But just tell me about. Think about you said, because it doesn't really matter that much to unless you're working on it. But how many miles would be the limiting factor roughly in regular miles? About.
Like I said, hang on, let me find the calculator. It's about 280 miles instead of. And at 280 miles, we could see, the radar was taken out of service in about 1991. But in 1991, we could see any aircraft that was in service with any air force in the world at 280 statute miles, as long as it was over 56,000.
As long as it was under or over?
Over 56,000 feet. Oh, and that includes the Lockheed F-117A Nighthawk, aka the stealth fighter or bomber or whatever you want to call it.
I got you. Would you consider that that it's potentially that since the air is denser down toward the ground, that it's possible that you're getting a longer signal in the thinner atmosphere? Is that possible?
No. I said right at the very beginning, standard refraction is essentially zero because of the wavelength we're using. It just goes in straight lines.
There's mediums. It could do it in water too. Then
you can't actually transmit RF through water. It doesn't work.
Our radar doesn't work in water.
Yeah.
Well, yeah, we have more water in the atmosphere the lower down. I mean, I'm not saying that's the limiting factor. I'm just, trying to get you to, think about shit like that, because there's more humidity down lower to the ground. Not talking about the clouds and shit like that, but as far as
by the
humidity,
way,
there's a gradient that gradiates down to zero at a certain height.
Humidity actually makes the air less dense, not more dense.
I understand that, but he said it doesn't work through water, and so if water is a limiting factor, or water vapor.
It's not water. Water isn't a limiting factor. It doesn't work underwater in liquid water.
Go put your 5 gigawatt
transmitter
horn in water and key down the microphone and see what.
No, I'm not making claims. I'm trying to learn to see possibilities. So if in fog, it would work the same pretty much through clouds and all that.
Yeah.
Clouds
That's
didn't
a real
affect
big difference in density between fog and a lake of water.
Yeah, I've got that. I'm not talking about water no more. Liquid water, I definitely ain't. When he said no refraction, then that made me think, then the median didn't matter as far as humidity or water. But I guess if you go all the way down to liquid water, then yeah, it doesn't work. I understand that. I'm not going there again. What I was wondering is if clouds might have slowed it down, or clouds.
If the water droplets in the clouds are big enough, then we would get returns off them. But we would just see them like any other target, and you could still see aircraft inside the clouds. You could still see the aircraft inside those clouds that you could see that you were getting returns off because of the size of the water droplets.
So it was always the same distance. Let me find a way to ask this. You always had the exact same distance coverage, no matter what.
The maximum range of the radar is fixed by engineering requirements.
Down to the dot.
Well, yeah, ours was literally hard limited to 450 kilometers, because you fire the transmitter and then you have the receivers open for 3 milliseconds, and in 3 milliseconds or 3,000 the signal can travel out and return 450 kilometers, 300 radar miles. because that's why we define a radar mile as 1,500 meters, because it's the time it takes for a signal to go 1,500 meters and come back. Because, you know, light travels at 3 times 10 to the 8 meters per second. So if you halve it, that's how far that's how you work out and that's why we use this radar mile at 1,500 meters instead of 1,609 meters for a statute mile.
But it detected clouds, though.
Sorry?
You say it detected clouds?
Yeah,
clouds?
you will get returns off big raindrops. You'll get returns off big raindrops that are flying in close formation.
What's it reflected off of? Just for my personal knowledge, what's it reflecting off of at its limit at 450 kilometers to come back?
Well, a target, if there's one there. If there isn't one there.
Gotcha.
If there's no target, it doesn't reflect. The thing is that after the length of time that gives you a range of 400 kilometers, we turn the receivers off, okay, and then we leave the receivers turned off for 1/3 of that time again before we fire the transmitter again. That way, we don't get any signals that have come back from a bit further that get kind of caught up in the new pulse that might have been fired. So we have a gap where we turn the receivers off, and so by the time that extra bit of time is finished, there's no possibility of a signal coming back.
Yeah, well, I thought there was a zone though, man. Like a 50 mile, like if you're 50 miles or 100 miles away from the radar. I thought there was a zone like where you could fly under these fucking things.
Yeah, that's because there's a thing called a radar horizon. And there's only a radar horizon because the Earth is a sphere of 6,370 kilometers radius.
Oh, you mean if it wasn't a sphere, I couldn't fly under the radar?
No, you couldn't.
Wait a minute, wait. If it's just the Earth blocking it, and I'm flying above that, you're contradicting yourself, man. Just stop and slow down and think for a second. If it's the Earth only, it's blocking the signal, okay? Then any plane flying above that said Earth could not fly the radar because the only limiting factor is the ground itself.
Yes, but the problem is we're actually firing. Remember, radar's pointed up a little bit. Okay, radar is pointed up a little bit, and that's why you get the 3,000 meters at 200 miles.
So it's not Earth curve then. It's the angle that it's pointed, right?
Right. The difference between the radar horizon, we point the area. If we point the beam up a little bit, like half degree that we talked about, over a flat surface, we would see every target above 3,000 meters. Okay, and as Blue said, it's actually 28 and change. But I'll give you a bit and give you 3,000 meters.
For it to be proved to me, you'd have to angle it down a little bit. Because you just proved it wasn't just the Earth curve; it's the angle of the radar. So if you pointed one of them things down, you might convince me a little more.
I can't point it. If you point horizontally, right? What happens is you get returns. You get returns from ground targets out
closer to you.
Why would that happen if the Earth's curving down and away from the signal? Why would you get returns from shit down there if it's the ground dropping away from the signal source?
You've got tall stuff sticking up into the beam out to 20 or 30 miles. And you know,
So not Earth curve then. Not Earth curve.
Brian, I think you're being deliberate.
You might be right, man. I'm just getting you to think a little bit with me. Is all I'm doing, man. Maybe being a little too over the top, but
The point is that we've got the radar right on the radar's right on the coast. It's basically looking out over the sea, but we point it up a little bit just because we don't want to get zapped with really powerful returns from ground level coming in, even when it's just not that far away. I mean, usually we actually blank the first 20 miles anyway, because you know it's just full of ground clutter.
If it's that close, you already got problems.
Yeah, because you know, understand things like church spires and stuff will stick up enough that you get returns off church spires, or you know, all sorts of odd stuff sticks up enough that you'll.
Alan, what is the beam? What is the beam width of your radar typically?
Sorry.
What is the beam width of your radar typically?
Okay, the system I worked on, because it was what they call volumetric, so it could height finding as well. So it was a stack of 12 overlapping beams. Okay, each beam was 1 degree high and half a degree wide. The bottom beam was angled up at 1 degree at the centre of the beam, and then each of the other beams were at 1 degree intervals. And of course, we're talking about minus 3 dB for the beam widths.
Right.
So
right,
no divergence. No divergence.
No. Actually, the whole thing is it's a 1 degree divergence, but that means that if he's shooting it up 1 degree and it's 1 degree beam, that means
Right.
that half
I meant besides the angle that it's set at. Is what I meant.
That means that one half of the beam is going down more towards the ground, which is that 3 dB point.
Yeah.
So you're only a half a degree up over the horizon.
Yeah, and that's what I've based the figures for the heights on. Is that
So how high was the tower? How high was the signal source?
It depends. In low power mode, remember we could actually stealth bomber at maximum range in low power mode. In low power mode, we had 2 transmitters running at 5 megawatts, at 4.5 megawatts each, because you did wick them right up in outside of.
No, I'm asking for the height. The height of the signal source. Of the height.
The height of that aerial. That aerial is about the center of the aerial is about 30 meters. About 30. Hang on. Let me again. I got to look it up because I don't want to.
No, that's good. Yeah, I'm not trying to pin you down or nothing. I'm just trying to get a visual in my head. And so if it's about 100 feet, 80 feet, or 100 feet, or something like that, that does what I was needing.
Between 100 and 120 feet, 35 meters.
The aerial height above the ground at Neater's Head is 21 meters. Is approximately 21 meters to the center of the aerial.
That's on a hill.
Okay, 20 mile inactive zone.
Well, the display when you actually put the display on a console, you tend to block it from displaying the first 20 miles because it would just be a big bright blob. The elevation at Neater's Head for the building is 10 meters. So the aerial height above mean sea level Newlyn is 31 meters.
Alan, when you say aerial, do you mean dish antenna?
I mean the dish antenna, yes.
And
Okay,
the
'cause
source, how high did you say the source was? 60, you say 65 feet for the source signal?
The center of the dish is 21 meters above the ground, and the ground is 10 meters above sea level.
Okay, that's about what I was thinking in my head.
I say if you look in the disc, if you look in live chat in the server, there's some photographs of there's a photograph of the transmitter price, the transmitter amplifier, and the waveguide, because you can't just use wires to move 3 gigahertz energy around at that power level. You actually have to fire it up. You actually have to fire it up very carefully sized metal copper pipes.
We call them waveguides.
Waveguides, which work exactly in the same, which actually work in exactly as optical fibers do. It's a it's a pipe that guides the radio energy instead of the light energy, and then it gets there's a whole stack of feed horns. Let me see if I can find a better view of the aerial with the feed horns.
And that half degree Alan's talking about, just to give you a point of reference, is about the diameter of the sun or the moon.
Right.
That's a half degree.
Right.
So that's pretty damn flat.
That second photo of the I'll keep calling it an aerial because we all. I mean, I know it's a dish and it's a dish and everything, but yeah. So there's a stack of 12 waveguides in the big horn in the bit sticking out in front, because I mean it looks somewhat like your satellite TV dish, doesn't it? And but instead of having one pickup, it's got 12. So it can so that it can do clever shit basically. But I mean, as I said, we could detect a stealth fighter at 280 miles, 280 statute above 56,000 feet in low power mode. And low power mode was basically using 10 megawatts of power. High normal power mode, 60 megawatts output into 12 beams, and high power mode was the same amount of output but only into 6 beams. So we basically put it into half the volume of sky.
Well, have we successfully beaten radar to death now?
Yeah, I'll shut up for a bit, shall I?
No, I'm just thinking about.
We learned that Earth curve ain't the only limiting factor. We definitely learned that, but it could be a good evidence.
No. You know, Earth curve is not a limiting. The range is only limited by the fact that we have other parameters that we have to adhere to that cause that. Because return signal power from a standardized reflector decreases at in an inverse fourth power mode. Because, you know, you have inverse square law going from the aerial out.
Both ways, yeah.
And then you have inverse square law of the return signal from the target coming back.
Right.
Yeah. Now, I meant we could fly under the radar above Earth curve and still not get detected.
No, you can fly. You can fly below the. You can really only fly below the radar because the Earth is curved, and therefore we have. Therefore, you say at 108 at 200 odd miles. Yeah, you've got to be above 10,000 meters, which is about 30,000, in order for us to see you. If you're below that, then you're below the radar. We won't get you because you know you're behind the horizon.
All right, guys. I'm at this point going to say goodnight to YouTube. I want to thank everybody that showed up and listened to all of this tonight. We covered all kinds of different subjects. I think it was pretty interesting myself. And we've had a lot of people hanging in there, anywhere from 60 to 70, pretty consistently. So thank you very much, and thanks again to everybody that gave us a super chat there. I really appreciate it. And with that, unless anybody's got anything else, not related to radar, anything else they want to bring up before I turn this thing off, now's the time. And I take that as a no. So good night, YouTube. You guys be careful. We'll do it again real soon.
Yeah, see you all later. Oh, see some of you tomorrow for Terry's live stream on the Aussie Perspective.